learning how to build and operate your own SatNOGS ground station, the very last topic of the day from the 2019 TAPR Digital Communications Conference in Detroit. This was a 4-hour-long session, about 3.5 to 4-hour-long sessions on Sunday morning. They started at 8. They took a couple breaks. They ended around noonish. So between 3.5, 4 hours worth of video. This is a long session, so get ready.
Shut up and sit down.
Hey guys, welcome to Ham Radio 2.0. My name's Jason. I'm KC5HWB. I'm very happy to report that this is the very final session from the TAPR DCC. I'm happy to report that I'm finally getting them all posted. That's the thing. So this is going to be a 4-hour-long session, okay? Well, again, they took a couple of breaks in the middle, so it's actually probably closer to 3.5 hours, but I decided to put it up all as one video because on YouTube, there's a newish feature that will allow you to skip forward. So basically what I'm going to do is I'm going to take the video and put it all together, which is, it's almost done right now at the time I'm recording this intro. And then I'm going to split it out into sections and say, okay, this section is for this section is for this section is for this. So if you go down into the description on YouTube, you will see something like this in the description. 1, 2, 3 here. And then the 1 is the very beginning of the video, so you don't need a link for that one. And then 2 starts at 21:53, 3 starts at 48:20, and 4 starts at 1 hour and 12 minutes and 8 seconds. This is one of the HamSci presentations. So if you click on this link here, you'll notice these are highlighted in blue. 21:53 is in blue, 48:20 is in blue. If you click on 48:20, it'll take you to that point in the video, 48:20 right there. So the good thing about that is that it allows you to skip through a very long video without having to actually watch it and fast forward and kind of move the slider back and forth. You're like, oh, there's a topic that I'd like to watch. Or you can kind of watch, you can see how, like if there ends up being 5 or 6 topics in it, you can see, okay, each topic is 30 minutes or whatever. You can watch this topic and then you can go back to it later and start on the next topic and start on the third topic and start. So it's a newish feature that YouTube started putting in the description links not too long ago, and I thought it would be useful for this video. So I hope you enjoy it. Thank you for watching. Put your comments below. 73.
Okay, welcome everyone to bright, sunny Sunday morning. And I see a couple of new faces who've just joined us today. Welcome. So we have a really good show. Amongst us experimenters, amateur radio operators, geeks, and nerds, we have our super people. So we have 2 super people here. So we got Corey Shields and Dan White, and they're here to make us a lot more wiser about SatNOGS and how to participate with SatNOGS. So I'm going to turn it over to them, and we'll go all the way up until noontime, and let's see what we can learn. Gentlemen?
Great. So quick introductions, and then we'll get into the format for this morning. I am Corey Shields, call sign KB9JHU. I live nearby in South Central Indiana. My day job is working for Mozilla, the makers of the Firefox web browser. I'm an IT guy, and this SatNOGS project is just a hobby of mine, so it keeps me off the streets at night. So disclaimer from my end, I'm not an RF engineer, I'm not an EE. I put the amateur into amateur radio, but this is really exciting stuff. I'm pretty excited about it. Hopefully get more of you involved as well.
I'm Dan White, AD0CQ, and that was a sequential call sign. And it was issued on December 12th, 2012. So the vanity call's not for me. Valparaiso, Indiana is where I hail from. That's northwest Indiana. It's about 90 minutes from Midway Airport. So it's really, it's nice for that. Electrical and computer engineering professor at Valparaiso University. Send your kids there, or grandkids there. Thank you, George. And if you come take a visit, please come take a visit. And if you do take a visit or know somebody, you can actually ask for me by name, and I will give you a tour, is how that goes. So I want to give a shout out to Part 97, 113.333, and that's it's a slight carve out for educators. If not for that, I would not be doing much in amateur radio until I was well on the other side of my career.
So we've got a lot to go into this morning. As you know, we're going to go probably all the way till noon. We'll see how things go. We do have a break baked in halfway through. We wanted to design this to be a progressive tutorial, if you will. So there are some hands-on exercises. If you brought a laptop, you can feel free to play along and try some of this stuff out. If you didn't, that's fine too. We're going to walk through everything on the screen, so if you just want to sit back and soak it all in, that's totally cool. So in the start, we're gonna go through what SatNOGS is, some of the steps to getting started, how to get a client set up on a Raspberry Pi, how some of the data works and the flows work from one application to another. Then in the second section, we're going to get into some of the hands-on exercises of using the database website, using the network website, getting into the new dashboard system that we just recently released. After the break, we will get into diving into a little bit more of building dashboards. So we'll do a couple of example dashboard objects where you build a graph and a couple of objects out of dashboard queries. Get into how the contributions work and some of the back-end code. At the end, we will dive into a little bit of the details in GNU Radio, as well as an exercise on developing a decoder for actual telemetry frames. Assuming we have time at the end, we'll go over some future roadmap items, and I've got a slide full of cool links that we can show off if you're still awake by then. So.
Okay, so the plan, if you're going to build a satellite, especially a CubeSat, maybe a university, or if you're a first generation satellite maker, is you build the satellite, and then you start dealing with your communications, right? And then you find out that's a lot of paperwork. So you head out and target using amateur bands for your downlink. Okay, so after you do that, then you build your ground station, get a launch, just those pesky details of that. And then, after you've launched, and you realize that your satellite doesn't come over your head all of that often, but now you are intensely interested in what happens to the satellite, you say, help! All right, so that's been the plan before, and people are finding out that's not quite as workable. And SatNOGS can help out. We can be ready for launch, and I think we've caught telemetry from some satellites recently on basically the first orbit after they come alive. All right, so doing this back in the olden days. When I say olden days, you can still do this if you wish, and sometimes you need to if it's not all automated. So you have orbital predictor, gpredict or Orbitron, SDR Sharp or GQRX for your receiver, for your software receiver, other decoders and such, and then you can get data packets. Then you copy paste these, send them into an email it back to the satellite operator, and they are eternally grateful. They will remember your name forever. So some of the issue is maybe planning, dealing with how amateur bands downlink, but CubeSats and small satellites are just a humongous thing now. It's been exponential growth for a long time, and it's not quite Moore's Law for satellites, but the plots sure look like that. So we have hundreds of satellites and small satellites in space. Some of them are commercial and therefore just totally ineligible and for using amateur bands. But many of these are available.
Just an example, this is a slide that I pulled out of a presentation I did back in July. So I just kept this 3-week span. June 17th, we had 3 new satellites downlinking in the ham bands. June 25th, 9 new satellites in the ham bands. July 5th, 12 new satellites downlinking in the ham bands. One of those was included the LightSail 2, which was very popular as part of the Planetary Society and the connections to Bill Nye. But a lot of people are familiar with AMSAT and the satellites with transponders and repeaters on board that you can talk through. We've got a good couple of dozen of those in orbit and operational today. What some people don't realize is that there are a lot of satellites out there that are downlinking their data in the ham bands. So the model of manually collecting this data doesn't scale, and that's where SatNOGS comes in. So our plan is, and the project, the whole idea in the last few years of this was to automate the entire process as much as we can via software and low-cost components, software-defined radio using RTL SDR dongles, single-board computers like the Raspberry Pi, and you automate all of those steps that Dan talked about in the prior slide with the tracking of the satellite, automate the process of controlling a rotator, automate the process of manually, or automating the process of the Doppler shift and correcting for the Doppler shift in the RF, automate the demodulation of the signal, and if possible, if we have telemetry decoder information for the satellites, all the way to decoding the actual telemetry for the satellite and making that data freely available for satellite operators, for researchers, for citizen scientists. It's a big theme this weekend, and there's a lot of opportunity for that here. And keep everything open source, open data, open hardware.
A little bit of history about the SatNOGS project. It started in 2013, or the end of 2013, at I think it was the NASA Space Apps Challenge. And one of the ideas was put together by a group in Athens, Greece. Came up with the SatNOGS idea, the core of that. And then right away in 2014, the website, hacker blog, Hackaday, ran their first Hackaday prize. And it turned out that SatNOGS went all the way and ended up winning that prize. It was about $200,000 top prize, which was, as you can imagine, a good catalyst for continuing this idea. What they did is the people involved rolled that into a nonprofit in Greece and called it the Libre Space Foundation, founded to design and develop open source technologies related to space. That includes more than just the satellite ground station network, SatNOGS. It includes some open source rocketry, satellite hardware. When I say satellite hardware, what was that, 2 years ago, UpSat?
Quite a few, yeah. Yep.
So UpSat was a partnership between Libre Space Foundation and a university in Athens, and got that launched as part of a ESA project. And we got some data from that. That was really cool. It was over our head during Hamvention, I remember, in 2016?
It's the open source satellite. All of the information around that satellite, open source and available online.
We're including getting into more software-defined radio and participating in making GNU radio modules and other technologies. Many of these are even used by commercial and government space things, like CCSDS is a communication format. and we're working on open sourcing or getting libraries, creating libraries that we can use with that, because most of them are still proprietary. Pocket cubes is a new development. So CubeSats are 10 centimeters on a side. They're measured in CubeSat units. So 10 centimeters on a side, a cube. A lot of CubeSats now are 3 by 1. You just get more solar panel area and such. Pocket cubes are smaller. They're several, maybe 30 centimeters on a side. You clearly can't put quite as much in there, but way back at $50 sat, that was a demonstration that you really can put a functional satellite, have some telemetry in a spacecraft that big.
Or that small.
Or that small. So, all right. So even though SatNOGS started in 2014 or 2013, depending on how you count, this plot starts in 17. It took that long for us to kind of get infrastructure and work on it. Back in 2017, we were not doing tutorials on how everybody can start their own satellite ground station, because you had to know 3D printing and solid modeling and compile your own GNU radio modules, and what else?
Installing Python packages. Yeah, it was a mess.
It was a bit of a mess, yeah. All right, so if we come back, I want to point out 2 points on here. The first point is we started creating a Raspberry Pi image based on Raspbian. A Raspberry Pi, everybody knows about this. And so we have a custom image, starts from the base Raspbian Lite, adds all of the packages pre-compiled, ready to go. So you can flash it onto on your SD card, and it's all ready. And we'll demonstrate what this looks like. It's you can have at least the software up and running in minutes. It's usually you're just waiting for the flash card to go if you're up to speed on what the procedure is. It's very easy. I'm super excited about that. That other discontinuity was just a change in how we did stations on the network, and basically made it totally opened it up. You make an account on the SatNOGS network, and then now there's no staging area where you're on the development network testing your station, and then you request to get on the live network. You can go directly to on the live network there. That was just a natural discontinuity because people that were in testing got converted there. Oh, let's go back to the slide. I did a talk at a conference called SmallSat, which is where kind of all the small satellite people go in Utah last year. And when I did this slide, I made this slide. It was showing this growth, but if you see an exponential sort of figure, it doesn't matter what your zoom level is. It always looks the same because it's an exponential. That plot topped out at 50. And that was 14 months ago. So,
Yep.
It's
Good growth.
yeah, it's pretty cool. Yeah.
What's the spike that goes up almost to 225 and then goes back down?
So the question is, what's the spike here? Wrong mouse. What's the spike here?
Sorry to interrupt.
I don't know. We'd have to look at the date and see what was going on. I don't know. That's a great question. It was really easy back in the days of like, oh, we're growing really big. Look at this. We get 5 more stations and it looks like a discontinuity. Now it's just noise. The cool thing is it's like you say it's noise when you're looking at these scales, but these are like individuals like you guys that are putting your own station on and getting excited about it. I just don't know all the names of these people anymore.
And now I'm interested, and
We're going to check it out.
we'd be distracted by this the rest of the morning. No.
Yeah, another question.
Charts at daily active stations. Maybe you want to take a day or two off and cool down and then get back on. And if they're tracking it by the day, that would explain the noise.
Mm-hmm. Yeah, this is just stations that have actually done an observation within that 24-hour period. So this doesn't include people that are all testing and and
Yeah,
such.
we have about, as far as registered stations, I think today we're about 4 times this. But somebody may have a nice satellite ground station at home for working satellites on a Yaesu rotator, and they're working satellites on the weekend, and then during the week when they're not using it, they throw it on the SatNOGS network. So, yeah.
Yeah. If you go to the homepage, or this is not the homepage, this is the homepage of our network, and it shows a live map. The green ones are stations that are open for scheduling by anyone else on the network. We'll talk more about the permissions of how you can schedule stuff. Anybody can use the website to download the information that's made under an open license, but to schedule on other stations, at the moment we require you to also be operating a station. So, as you'll find out today, the bar to operating a station is getting lower and lower and lower, and that's exciting. This is zoomed out because we do have stations all over the planet. We have one that's going to be going in from some South African friends to a station in Antarctica, and we'll have all continents covered. It's kind of my hour, isn't it?
Yeah,
It's all right.
I'm still waking up.
My coffee's over there. All right. So, in 2016, the recent last Chicago DCC, I did a talk about SatNOGS, and it was really this first section. This is kind of an overview of the network, what the modules are that hook this together. As Corey said, in the second section, we'll take a short break and show you how to use this from a user's point of view. So I swear that these slides are not copy-pasted from that presentation. All right. So our reference station for running a SatNOGS station now is a Raspberry Pi 3B. The B works fine, but the 3B Plus is the current model. And use an RTL SDR dongle, which everybody has more than one, I'm sure. And really, the sample rate is limited by what your Pi can process. So I don't know that we've been doing much testing on the Pi 4s with the USB 3 connector. But really, to work with SatNOGS at present, any SDR that works with Osmo SDR already works with us, because that's their driver under the hood.
With the exception of the FunCube dongles, but that's a totally different exception.
There's always details, right? All right, so if you, of course, we're going to recommend you running in a low noise amplifier, and you all know that if you're picking up weak signals. LNA for all, there are other LNAs in the works. We've got an open hardware LNA design that makes it even easier. The current LNAs, there's a little bit of assembly required to get them powered up and such. As a note, just with this is our new Raspbian image that we can flash on. That was we just pushed out last week by some core contributors. It now includes all of the software to get the BIOS T. The RTL SDR blog V3 dongle has a BIOS T that's built in to the hardware and controlled by just by the driver. That BIOS T now works in the software that we're running that's on the image. I'm really excited about that because my antennas are going to have an LNA when they go back on the roof. All right, so this is actually the last Hamvention. You can bring your own rotator. If you already have a rotator, anything that speaks to hamlib works with this. So we talk to hamlib. You configure hamlib to talk to your rotator, and we don't interact with your rotator directly. So if you already have a rotator under computer control, unless it's a totally custom thing, your rotator is going to work already. Alpha spin, portable rotation, of course the G5500 are common rotators. That's on the budget side, or that's on the larger budget side, right? If you have a G5500, your Raspberry Pi, if you step on a Raspberry Pi, you're not sad. If your 5500 goes bad, you got to climb on the roof, which is no fun, and it's many Raspberry Pis. You can also Build your own rotator. We have plans for building your own rotator. But as you see, there's a portable rotation, an alpha spid, G5500, many sorts of antennas that you can put on here, rotator or rotatorless. And it's just a nice picture. This is Corey's, the one in the upper middle is Corey's place. He's got a nice view, nice horizon.
Yeah, I have set up the 3D printed rotator. It's a bit of an addiction. Once you start with an Omni station and want to make it better, you move on to building a rotator, and you want to make it better, you move on to commercial rotators and bigger antennas and on and on. So it's a word of caution if you get into this game. It can be.
I think if you're sitting here now, you already know.
Yeah.
Going down a path. All right, so if you want to start, the cool thing is you might want to start with building the rotator, maybe the 3D printed rotator that we have, and that's actually maybe not the best way to start getting into SatNOGs. Just start with an Omni antenna. If you have something on your roof, you know that on the RF side that you're going to be disadvantaged, right, from a 40-element Yagi or something. So you kind of know what you're going to expect for receive performance. But the rest of the system you can get bootstrapped and going using Omni antenna. There are lots of designs. Students talked about a QFH design. That QFH design came from last year's QST. I think it was May 2018, and that's the one. So there's also commercial antennas, and if you see the bottom antenna hanging off the gutter, that's a 3-element Yagi. Just point it up. No rotation. I think the elements are east-west, you said?
Yeah, I've got a couple of examples using this one a little bit later, and we'll come back to this one. The interesting thing about this project, when it was first started, the assumption was that we would need high-gain antennas and therefore directional as-L rotation to be successful with collecting data packets from CubeSats in low Earth orbit. What we found is that people started popping up on the network with omnidirectional antennas, and they worked. So now there are a lot of documents on the wiki on how to do this, what works, what doesn't. As you notice with the Yagi, there is an amplifier there at the mast, and that's always a must with an Omni. Question in the back.
Yesterday, a comment was made that most of the satellite orbits are more or less on the horizon, and you really want the Yagi pointing up versus pointing out.
So the question is, Bob, I don't see Bob in here. Bob has a page on the APRS site that shows the majority of the satellites are going to be in lower elevations, and so we don't necessarily have to have elevation rotation. And yes, that's one way of looking at it. The opposite for this specific case with this Yagi is that in the SatNOGS station configuration, we allow a minimum horizon. So if you've got trees all around you and your minimum horizon may be 20 degrees around, you set 20 degrees. This individual set it at 35 or 40 degrees. So it's the opposite of what you're suggesting in that they're only going to be focusing on passes that are going mostly overhead, but yet their success rate for those passes is going to be greater because of that Yagi and the beam width. So to further answer your question, there are some feature requests that we have for network to go beyond just a minimum horizon, but also a maximum horizon, which would account for the lower elevation angles, as well as blind spots, because there are some in every situation. So, yes. Yeah.
Do you have a problem with polarization?
Question is, do we have a problem with polarization? Not really. There's always going to be, right-hand polarization, left-hand circularized polarization. In fact, some of these antennas that you see here are going to be that way, and some of them, all these cross Yagis and the helical are that way. There are a couple of cases where the polarization really counts, but what we've seen is that you're able to pick up data in many cases regardless. That said, again, going for that better next step of making things better, there are some vendors who have polarization switches for right hand, left hand, and some people are testing ways of setting the polarization of an antenna for a pass. What we don't have today is that pipeline of a setting from the satellite perspective saying this satellite is going to need right hand or left hand all the way down to the client. I'm sure we'll get there someday, but right now, I've seen people on the ground, the network, who have a simple mag mount antenna on a huge ground plane of metal, and it works. It's not perfect. It's not going to be producing what you get from a high gain antenna, but in this kind of a scenario, if you can have 20% efficiency versus none, then that's 20% more than what you had before.
Along with the rotator, and many passes spend most of their time at lower elevations. I'm not directly aware of any station on our network. There's enough now that I don't know of everybody that has just an azimuth rotator. Anybody that has a rotator has azimuth and elevation. You go up to the larger antennas, but I don't think anybody's running just an azimuth antenna, a little wider beam width, which is exactly what Bob's talking about. Like, you don't need the elevation rotator. You just spin around and track the azimuth. So if you want to do that, that's an open question. We have Omni stuff. We have higher performance stuff. In the gap, how well does the gap do with just an azimuth rotator? We can run simulations and guess. And here's the cool thing with SatNOGS: you can just put one up and let it run and see what you get, and do some quantitative looks at how does this perform in the real world.
Yeah, I know from the software perspective, from the clients, again, going back to that no elevation rotation, you just plug HamLib into your rotator and set it up, and the client's going to tell HamLib to go to 270 and 45 degrees. HamLib is just going to throw the 45 degrees out and say 270. So it's something that could be tested and tried easily by somebody who has that set up.
Just nobody's done it.
Yeah.
The bar's so low. Drives me crazy because I ain't got time to do it. I have a day job. Okay, so this is the hardware side. And this is the visible part of the station. We do a SatNOGS demo. Now another contributor near Chicago, dropping his call sign. He made this world plot. That's a real-time plot of what satellites are overhead, what stations at any time on the network. That's really cool, just using our APIs. You can go to the next slide. So we have, there's a lot of software components to this. I'm going to give a tour of kind of like what it looks like, and then Corey's going to fill in on how these modules are connected together. One of the first things, so you think we need the website that holds, does all the scheduling or handles the scheduling, communicates with the ground stations. But if we're going to automate this, we need like machine-readable information, right? So there are nice websites that collect information and frequencies and what the payloads are of various small satellites, but it's not machine-readable. So immediately when the project started, we're like, hey, looking around, let's find a database of satellite information. But scraping HTML is not the path that you want to go down if you've ever tried that, to scrape web pages. So we need machine-readable stuff. This is what we call DB. This database has information that you would need for tracking satellites, what the satellites are, a way to get their current elements. They're two-line elements. The third line is just the name. But it's still a T, isn't it? Every time I talk, like every set of new students, I'm like, and then there's these TLEs. It stands for two-line elements, and I'm showing them 3 lines, and they just look at me like, mm-hmm. Okay. So
you're getting that look right now. from your students.
Oh, I'm used to it. I'm used to it. All right, so on the database, this is crowdsourced, which means in one way, there's not a central person really that manages this. There was like 2 people that entered most of the data in the first round. But when there's a new satellite that are launched, if you've been aware of satellites, Corey's mentioned that just one launch had 12 new satellites at once. So if we want to catch these ahead of time or within the first orbit, we kind of need to enter this information in the database ahead of time, because this is where the rest of the network knows where to point antennas, how to do the Doppler correction and such. So I'll show you a little later how to, if you know of some information, you've kind of seen that a transmitter is drifted from what the database is saying, because this is what happens, right? We have hardware that's just aging in space. We want contributions back, so you can log in, make some suggestions of how these are, and then we say thank you, right? This is a crowdsourcing thing. The database also holds telemetry data that we download. This is the data that gets the binary information. This is not the waterfall data. Well, we might do the waterfall data. Ask us next month, right?
Today.
We've got a big meeting next month.
Frames. Data frames.
Data frames, okay. All right. Also, DK3WM, WN, he has a telemetry forwarder, so we now are the back end for that, for his database. Also, GNU Radio satellites. SIDS is another telemetry format from Daniel in Spain, and we're collecting those, the back end for that. As an example, gpredict, the Linux tracking software. Chet, he's also part of SatNOGS, so that's really cool. We're using his stuff, and then he got involved with SatNOGS because people were asking him questions, and now when he ever visits the European Space Agency, he just walks by and he sees his software running on ESA machines. It's the first time he saw that was pretty cool. I think someone was demoing, just giving a tour, and they're like, oh yeah, and then there's this software that, that you can track satellites. It's all for, open source, so you can run it yourself. Have you ever heard about that? And he's like, yeah, I wrote it. Okay. So because all of this database, we're taking an open approach, you can download this information too. We'll show how you can get this. You can do whatever you want with this information. And go from there. 46 million frames. Most of those frames are from some of these third-party forwarders, and not from SatNOGS itself. As we go on,
Yep.
Why not? I have a tracking app on my phone, just a commercial Android app, and it gets its satellite information, or some of its information, like frequencies and such. If you look in the About box, right, since this is an open license, you need to properly attribute. They cite SatNOGS database as where they get their information. So some of this open source, you don't know who's using it until you just find out, because there's no requirement for interaction. We, of course, love the interaction,
Yep.
but why not? The next part is kind of the main hub of everything. We call this network. It's where we schedule observation, and observation is the word for the thing that you would call pass for a satellite. That also includes information for tracking it, frequencies, and such. So part of the interface for this is because now this network knows all of the ground stations that are checking in. That's where the green lights in the map. This is how the network knows who's there, because all the stations are just checking in. You can go into the interface and say, I want to listen to Upsat, or I want to listen to Fox 1A. It's kind of on end of life right now. It's kind of fun to watch it attempt to start up. And then it will compute the passes over all the ground stations in the network, at least the green ones that are online, and you can schedule those, and you can schedule many passes over many ground stations just from that interface. You can do it from the other way, just schedule single observations is another way to do that if you're interested in certain satellites or certain ground stations. The scheduling though, like I can schedule an observation on Corey's ground station and I don't even have to ask him. So when the stations are green on the map, if you're logged in, you can schedule on any of those as long as there's an open time slot. When it's finished, we display the observation, we display a time frequency plot, a waterfall, so you can see the signals. If there's audio or baseband audio that's demodulated, those are stored as OGG Vorbis files. Compressed audio, because just storing 5 minutes of wave files for as many observations as we're doing is it's a little excessive. Although you can turn it on and save it yourself, we just don't, the network, the server side doesn't store it for you. So I store the raw waterfall data on some of my stations so I can pull out, instead of the waterfall image, we can get them in scaled as spectral slices.
And the raw IQ data can be saved as well.
If you have lots of disk space, you can just turn on Save IQ for all of your observations, and then you'll need Node-RED and the tools I talked about on Friday to let you know when you're out of disk space. All right. So this is a recent, probably the newest aspect of SatNOGS, the dashboard. So we're collecting data, we're collecting the telemetry frames. If the satellite operators have given or made public how their data is encoded, we can now go from the bag of bytes and decode that into what these bytes mean, what the telemetry means. And as soon as you can do that, the next thing you want to do is plot it, right? Well, there's lots of other open source tools. Grafana is what is running this, and pull from the database, decode this as it gets pulled over. In the fourth section of today, we're going to show you how to write those decoders. It's pretty easy. You can do it in a web browser. If you've ever written a parser, a binary like frame parser, you know how much fun that is. This tool, it's not ours, but
You're not selling it. It will be fun, we promise.
Like if you've ever, written a decoder yourself. Yeah, it's no fun.
And we'll demo this as well, and third section we'll get into showing you how to build these dashboards too.
Yep. The tool makes it easy,
Yeah.
so the pain is much less. All right, so yeah, as Corey said, you can make these dashboards, and you can make your own dashboard if you don't like what you see.
Yep. Going back to the whole idea of the project, to be crowdsourced and get as many people involved as possible, the whole citizen science aspect of this.
Final part of the software is the software that runs on the Raspberry Pi on your hardware. We have, as I said, we have a ready to flash Raspberry Pi 3 image. It also works on the 4, the new 4. It checks in with the network every once in a while or every minute. It asks the network, what observations do you have scheduled for me? So the station itself doesn't keep track of that. Anytime you do scheduling, that happens on the network side. It's a web service, so you just do it on a web browser. But when the time for that job comes to be, when the satellite's going to come over, the client software is what handles managing the ground station. It will start commanding the rotator through hamlib. It runs in the orbital predictor, so to know where to point. If you have that, you can also do Doppler correction. You can compute Doppler shift on the fly. It starts GNU Radio. GNU Radio is how we do all of our receivers. That makes us able to add new modulation formats and such by adding a new GNU Radio script. And then part of the scripts, or part of the standard interface for these scripts, is one of the outputs is generating the waterfall. It's turned into an image as a post-process, saving the audio, and then when the pass is done, it shuts down GNU Radio, quits talking to the rotator, and then starts uploading data to the network. So that part, seeing the waterfall, doesn't happen until, say, a few minutes after the pass has ended. So, you know, if you're impatient and you got it right away, like I am, I'm just hitting refresh. I've learned to just go onto the Raspberry Pi and watch the logs and watch when the job fires off that it uploaded it, because then now I know that I can refresh the website. Refreshing before it got uploaded is futile. A cool thing, yes?
So once you deploy your ground station, it runs itself. You walk away and come back when let's see what it's been doing. Is that right?
Yeah.
You want to repeat the question?
Yeah. Once you deploy a ground station, you can walk away once it's set up. So, yeah, you can walk away if you make it open to anybody to schedule observations. So it'll just run observations that are scheduled as it goes. Of course, it won't do anything if there's no observations are scheduled. If it gets tedious to schedule these observations, there is kind of a backdoor way to automate that process. We're not going to really show you that because we're using some backdoor ways that aren't kind of require some manual information.
In development.
It's coming down the pipe.
Progressive.
Yep. So
but yeah, my ground station originally set up years ago, and the only time I've done anything physically to it is when I want to make updates or you know, actually upgrade the software on the Raspberry Pi, for instance. But otherwise, you know, I'm hundreds of miles from home, and the rotator's going and collecting all kinds of stuff. I've been able to capture, you know, first and second orbital data for new launches while I was thousands of miles away from home, just letting it run.
how many relays are you up to in your control box?
Oh, yeah, we don't want to get into that. Yasu might be watching. The duty cycle is a lot higher than what a typical weekend amateur AMSAT user would be using a rotator for. That's for sure. But we also have settings where you're able to tone that down. Let's say you don't want it to be used all the time. You can tweak that setting. Or let's say you want it, you want it online for a month, but you're going to use your ground station. You take it offline, you go into the network, and if there was anything scheduled for it, you can delete those. That's no big deal, and use your ground station for whatever you wanted on AMSAT. Yeah.
Can you command it to only operate for certain SATs?
So the question is, can you command it to only operate for certain SATs? No. There is a big driving concept here is, you know, openness and open space and trying to collect everything. There are a couple of forum threads on our community site. If you go and search for that question, to give you a little bit of the philosophy behind that, there is in the auto scheduling that Dan talks about that is in development. There's the concept of prioritization. So if you as a station owner want to prioritize you know, weather satellites, or you've got a certain satellite that you care about, then you could set that up through that auto scheduler. Mm-hmm. But as far as we try to avoid political debates and say, well, I'm not going to put my resources towards, you know, this country's amateur radio satellites. What we do want to focus on is promoting good amateur radio behavior internationally, doing proper coordination with IARU, for example, rather than trying to build a way that says, I'm only going to watch this or watch that.
Mm-hmm. So if you're waiting for your waterfall to upload at the end of an observation, a way that our telemetry generation does, GNU Radio takes the telemetry files, and every frame it writes a file, but it uploads it right away. So in the middle of a pass, you can see that I'm getting data frames if you're a chronic refresher. You just won't see the waterfall until
refresher.
Until it's done.
All right, so we've thrown out a lot of names and a lot of different websites, and it's going to be confusing for now. Hopefully in the next 3 hours it will start to come together. But this is what it's all going to look like in the end. And each one of these components kind of serves a purpose. Dan just talked about the client and the ground stations here, which feed into SatNOGS network. But as he also mentioned, we still have lots of other satellite enthusiasts and radio amateurs who are running other applications and collecting data for satellites, and in some cases, telemetry decoders that we don't even have support for yet in the SatNOGS network. So these other applications, the DK3WN and GR satellites, decoders will dump those hex frames, as well as SatNOGS network dumping hex frames into the SatNOGS database. From there, these are just hex frame representations of the telemetry that was decoded from the demodulated stream. So from there, we take those hex frames, and if we have a decoder written, and this is going into the fourth section of the talk today, our new process is to be able to decode the actual telemetry values, let's say battery voltage, or if there's a radiation experiment on board, the measurement of that. Anything that we can pull out of that, we then send to our data warehouse, which is a time series database. So if you've got a battery voltage an hour ago, and a battery voltage 30 minutes ago, and a battery voltage now, that is a time series piece of data. So we use InfluxDB as our time series database, and that gives us the ability to slap a dashboard in front of that and easily graph everything out. And not only graph everything out, but be able to then customize the time that we want to look at certain pieces of data. So we'll demo all that. And there are also future uses for this data that we haven't foreseen yet. Just looking for citizen scientists to get involved and give us ideas. So let's dive in. So if it were feasible, I'd have everyone here with a Raspberry Pi and a fresh image, and we would start off building the ground station on a Raspberry Pi. But to make things easier and quicker, we're just going to demo this up here and hopefully give you enough exposure where if you wanted to do this at home, you can go home and know how to do it. The reference image, the reference platform today is a Raspberry Pi 3 Model B+. We really need the multi-core CPU of the latest Raspberry Pi 3. Raspberry Pi 4 also works, but Raspberry Pi 3 is definitely sufficient for our needs. So if you've got an older Raspberry Pi sitting around, like a 1 or a 2, might not have as good a luck as the Raspberry Pi 3.
Well, I think more importantly, the 3 and above is 64-bit machine. The 1 and 2 are 32-bit machines. So I'm not sure the image would be compatible.
Yeah, the comment was the image compatibility between 64-bit latest Raspberry Pis and 32 bits. Yeah. There's that as well. The software itself is, the client software is Python, and the RF stack is Skinny Radio. So it is possible to run this on any Linux desktop. We have people who do it. It's just not for the faint of heart. So it's easiest just to throw $35 at a Raspberry Pi and get it up and running and dedicate that to the client. We've got Raspberry Pi, add an RTL SDR dongle. As Dan mentioned earlier, we do support most of the Osmo SDR supported dongles, soon to be the dongles supported by SOPI SDR. And everything from the RTL SDR all the way up to the EDIS, USRP series of software-defined radios will work with SatNOGS. The exceptions that Dan mentioned are going to be some of those devices, like the HackerF, which has a very high sample rate, is not going to be able to work well with the USB system of the Raspberry Pi. So while they are compatible, they would only work on a desktop. My suggestion is start with an RTL SDR. It's cheap. Yep.
What about the FunCube dongle?
So the question is about the FunCube dongle. So the FunCube dongle, the way that works is it sends its audio out in an audio device in Linux, rather than the way everything else does with Osmo SDR. And the sample rates that we get off of the FunCube dongle are not a sample rate that matches with the decimation that we have in the GNU radio scripts. So the initial decimation that we have is going to assume multiple 200, I think, and doesn't work with the FunCube dongle. So that's the short answer of why. Somebody could go in and change the code and change the entire GNU radio stack and make it work. So it's possible. It's just not something that somebody has done or documented. The easier answer to that is to buy a $20 RTL SDR because it works. It is, yeah, it is. And there are others that we use and we have tested on the network, and we've got users using on the network. The AirSpy is another very popular one. The Lime SDR has been under test with some of the changes to SOAPy that's coming up. So I think some of the changes in GNU Radio that we've got under development will open up even more opportunities for other SDR devices.
Corey, do you think we should support the Tangerine SDR? I sure hope those drivers are open.
With this crowd, yeah. No, and I'm sure it will be supported just all the same, as long as it's in the same, that same layer of abstraction for the SDR platform. But no, in my experience, I've used almost all of them. The RTLSDR.com dongle and all the way up to the USRP B200, and the improvement in the results are not that much. At least not enough to justify the added expense of the USRP. That's a great radio, and that's going to be more beneficial when we get into S-band and other types of observations. But we're getting started here, so this is a good first step. So start with the RTL SDR and build up from there. Work your way up from there. So downloading the Pi image. We have all of our instructions on the wiki. So wiki.satnogs.org. In fact, there will be slides with all of the links at the end of this, and as well as a link to the entire presentation that you can go to afterwards. So you don't need to remember this for now, but if you go to wiki.satnogs.org, there's a build link and a link for the Raspberry Pi.
Build is way on the top. It's next to the logo in the upper left.
What's that? Sorry.
Build is up in the top.
Yep. Whoop. There we go. Yeah, so build, when you get into this page, there's going to be this big download link. This download, our images are auto-generated through a build system in GitLab. So what you're going to get is a zip file, and you unpack that zip file, and inside is the actual image for the Raspberry Pi. So grab that image, unpack the zip file, and then find your favorite method of burning an SD card for Raspberry Pi. If you're new to Raspberry Pis, I highly recommend the Balena Etcher. It's a cross-platform application that will pick an image that you've downloaded, pick the SD card that you have in your computer, and with one click, do all the magic. So when this is done, you will have the SatNOGS image on your SD card. You can then go in here, and I'll show you an example on the next slide. This is all on the wiki as well. With that image mounted into your computer, be it a Windows computer or Mac or Linux, you'll have a FAT file system mounted that's called boot. And if you want to set your wireless configuration there, rather than having to log into the Pi for the first time with a keyboard, you can open a file called wpa-supplicant.conf. And that file will end up looking like this. So to get the Pi up and running, you don't even need to have a keyboard or a display. You set this file up for your wireless network, save it on that boot drive, slap the SD card in the Raspberry Pi, and then we're good to go. So let's go into a demo. And you have to apologize as we do these demos. I'm going to switch between mirrored and unmirrored displays. A lot of switching around. Hopefully you can see some of this text here. I have a Raspberry Pi over here running on the table with the SatNOGS image, and I've SSH'd into that and ran sudo satnogs-setup. It gives you this nice and easy menu. This nice and easy menu. And from here, all you need to do is set up your basic configuration. And in that basic configuration, there are a few things that you have to fill out to make this functional on the network. I will show you on the network side a little bit later where to get some of this stuff, but the first is going to be an API token. This is going to be specific to your user, and this is your key that links this client with your account. So I'm not going to show you mine, but this is where you would put that in. Next is going to be the RX device, in this case an RTL SDR. Station elevation in meters, and all of this is going to match the same parameters that you will put into the network site as well, which we'll show a little bit later. So this is kind of a backwards step. You would do this in the network first. Station ID, this is the ID for your ground station in the network. Each user can have multiple ground stations. So for me, this is just another ID number for this ground station.
He also holds ID number 2.
It's been a long time. Latitude, longitude. Rotator enabled. So if you have a rotator, if you have a Yaesu rotator, for example, this is where you would enable it, and the options for that rotator would go in here. I think by default, 601 is for a Yaesu rotator within HamLib. So this is basically telling the client to look for a rotator controller at this USB device using 9600 baud and expose that on the local network. That's it. Once you're done here, you hit apply. This is very important. If you don't apply the configuration, you'll lose it. So you apply the configuration. This application is going to go through a couple minutes of setting things up, making sure everything's up to date, and then once that's done, that's it. The client's ready.
Automatically restarts with the new settings. Once you hit apply, it does take a few minutes. So if you're impatient, just walk away. It's easier to do. And then it's ready to go, yeah.
So if you hear of a client update that we've done or an update to GR SatNOGS, which is our RF stack, all you do is run SatNOGS setup, come in here and update, and then apply again, and you're up to date. So it's all in this application. Question?
Is the image write protected so that you don't have to worry about?
So the question is the image write protected? No, it's not. It's basically a standard Raspbian Lite image built with the same toolchain that they have for their process. and then we slap our software on top of that, as well as the changes that you need. So you can actually go in and tweak it to do other things if you want to. You want to add some other monitoring applications that you like. I run some monitors on mine and some scripts on mine. So the answer is no. It's not write protected because we want it to be modular and want it to fit whatever you want to do with it. On that topic, though, there is always concern of constant writes on an SD card. With this custom image, we move the logging and temporary files that we write to memory instead of to the SD card. So we try to really extend the life of that SD card, especially because so many of our users are setting these up on top of the roof, and it's hard to get to once it's set up, and corrupt SD cards are a problem. So, good question. Next question.
The interface for the dongle, the SDR dongle is USB, right?
Yeah, the interface for the RTL SDR is USB.
And the rotator also is USB?
So the assumption is that you would have some kind of USB interface to the rotator. I say that because the Raspberry Pi is going to be USB. So if it's an older rotator with a serial cable, then you're going to have a USB to serial dongle.
How many ports, how many USB ports?
So on the Raspberry Pi, you get 4 USB, for the Raspberry Pi 3, you get 4 USB 2.0 ports.
Built in?
Yes, built into it, yes.
You can use USB hub and expand.
Yeah, you could add a USB hub. I would not advise putting the SDR through a USB hub, but yeah, if you needed more ports, you could break that up.
Mm-hmm. One of the biggest bottlenecks with using the Pi, especially for an SDR application, is actually the USB bus as implemented in the Pi. So we can't really even run the RTL SDR log SDR at the full its maximum sample rate, just because the USB bus can't handle that.
On the with the 4 you can't, and the 4 there's a forum post about the 4 if you want to check the initial results about the 4 and our client. Unfortunately, it's still not as good as it should be or could be for running, let's say, 10 megasamples off of AirSpy. So, but that could also be a factor of drivers and firmware catching up to the hardware. Yeah.
Do you see how there's an opportunity if you already have a Pi and an RTL SDR and you've played with these before? We just need somebody to do this, to poke at it and see what the real problem is. You know, sometimes you look on forum posts, you're trying to find issues to your problem, and all you find is everybody else is having the same problem. So, a few extra minutes of documenting your troubleshooting procedure with the way openness works nowadays is just a force multiplier. I figured out why a couple weeks ago why the bias T wasn't working on our old image, because all indications were that it should work, but it wasn't. We just needed somebody to sit down and track through why it was. It's not that I was doing anything special. I was just stubborn enough to figure it out. I turned around and then just wrote it into a forum post of, this is what I found. It's a version thing. The compatibility that was added in the library was 2 commits after the version that we're using of the RTL SDR library that we're using. That's why it doesn't work. So if you're welcome to recompile everything. I have wonderful news, because as of last week, our image just makes it work now. We upgraded some of those libraries. So we just need people to poke at some of this. If you're doing this, you go from user, you see an itch that you want to do, and if you figure this out, write it down somewhere. Put it in the SatNOGS forums, and it's super valuable information. You know that when you find somebody that's worked that out, and is maybe not a deep expert in everything, but it's like, this is how I did it, this is what I found, and this is how I fixed it. This is, that's the catalyst to just getting stuff done. It's really cool to see others doing that.
yeah, it's truly a community and a community effort. So definitely get involved, and if you have a question, ask it. Someone will answer, hopefully. And if you have a discovery, make it known. That's the cool thing about this project. One last point on SDR devices and sample rates. The higher sample rates are really not all that beneficial to us right now because a lot of the signals that we're looking for are such low bandwidth that we're going to be looking at a very small decimated portion of that signal coming in from the SDR.
So if you have a high bandwidth SDR, you know that if you run an omni antenna, and you don't need to physically point your antenna to get your satellite in the beam width, anything that's over your head is in your beam width with an omni. Well, in theory, all the signals are coming in, right? So you just run multiple receivers off of that single quadrature stream in software. This is the software of software-defined radio, and now you could run multiple decode. You could be decoding any satellite that's over your head. In principle, this works fine. You would not be doing this on a Raspberry Pi. You'd run out of horsepower, but there's really not much that's stopping you from doing that. Why doesn't SatNOGS do it? Because nobody's done it. Why not?
Great. So why can't I get that? There. Okay. So that's the Raspberry Pi. That's it. Flash the Pi, run SatNOGS setup, get up there, and there are other parts of that instructions in our wiki to get you to that point with the wireless configuration and everything. So with that, we go to the network side of things, and we'll give a more in-depth demo of this here in the next section, how to set up the station on the network side. But what you'll do is you'll look at the station page, and once the Pi is set up, you will see on the station page that you'll have this last seen 0 minutes ago. The Pi checks in once a minute, so if this is suddenly 70 minutes, then there's something wrong. Or if this is never seen, then there's something wrong. Otherwise, this is going to see, within the last minute, you're going to see that the Pi has checked into the network and everything's running fine. Initially, a new station comes online onto our network in what's called a testing mode. You see this with the bar up at the top and this little testing down here next to where the Pi is checked in. That means that you, as the ground station owner, is the only one, as well as systems administrators, who are able to schedule that ground station. This is useful to know later on. If you're changing your station up or doing something, just flag it in testing mode and set that flag in the station page, and nobody else can schedule the ground station.
The last seen 0 minutes ago, that status, you do have to refresh the web page. This is the origin of my mashing the F5 button. It doesn't auto-update.
Not today.
Not today. I'm not a web person, so I'm sure it's...
Somebody's going to watch this YouTube video in 5 years.
Yeah.
So next, there is an advanced settings menu in that menu that I just showed you. I'm not going to go back to it. I'm not going to speak to all of these by any means. I just want to show it to make it known that there is a wealth of settings and tweaks that you can make within your client. We offer the opportunity for pre-observation scripts and post-observation scripts with variables that get passed to those scripts as well. So if you want to do your own local processing or handling of an observation, you could do that too. The one thing that I think a lot of people end up looking for at first when they're setting up is RF gain, which is going to be the RF gain setting on your SDR device through Osmo SDR, and the PPM error if you have measured the PPM error of your SDR device. Most of the newer RTLSDR.com dongles are pretty spot on here. So, but once you get started, if you notice that your observations are off a little bit, you can tweak the PPM here.
Especially if you have the more generic ones and not the RTL SDR blog ones. those don't have as nice of oscillators on them, and you would want to tweak that PPM setting. I've not found a need to do it for the silver ones.
Yeah. And as I mentioned later on, as new software comes out, you can update through this same menu as well. Just hit update, and then apply, and reboot. Okay, that's our first section. Quick pause before we get into the second section. So let's kick off the second section of SatNOGS. We're going to get into some hands-on exercises and demonstrations about using the SatNOGS websites, the SatNOGS DB, SatNOGS Network, how to go through, schedule things, browse, and get you a little familiar with that process.
All right, so first up, I'm going to show what it looks like to interact with the database side. Day to day, you're not always interacting with the database, but this is crowdsourced. If you know of information that is incorrect in here, or if new satellites, frequencies are drifting on the satellite, and you wonder why nobody has updated it, it's because you're having the thought and not acting on it. So this is crowdsourced. There's really no barrier to doing it besides creating a login.
I'll interject real quick here the note that there's a lot of development and pipeline for the front end of this website. If you go there today, it loads way too many images that you're not going to look at and scroll through, and it's just not an efficient experience or user-friendly experience. So there's some plans underway to revamp that, make it more useful to our users, as well as provide a dashboard for hamsats that you could use when you're out in the field doing transponders and whatnot. So stay tuned. There's going to be a lot of improvement in this space.
You can see a preview of of some of those ideas. Corey has a forum post of what he's talking about in the forums. So if we're thinking about stuff, we got a mock-up, we have screenshots.
Looking for comments and ideas. So.
Positive or negative? Just positive. So if you
them
have,
all.
if it looks good, let them know. If you don't like it, then yeah. All right. So this is we're going to take a look. We're going to switch over to the live website. How do we search for satellites? When new satellites are launched, if you're familiar with the process, they don't get an ID from what is it, JSPOC? NORAD? It used to be NORAD, but now it's not, but we still call it NORAD. Just like the scopes that I use are all HP. But that's not what the label says on the front. All right, so this is this is live. So if you're looking for a certain satellite, just to look up some information on it, I've been liking to watch the Fox 1A, watch that observations. So AO85.
AO85.
So if you look at that, you can start typing for this. This is 40967. If you know the NORAD ID, just say 40967, and then we'll go all the way down to this. You click on the satellite. It loads up. It might have an image about it. It shows it where it is in its orbit right now. If you're curious, it's a live update. And then that's just kind of general information. This is really not the machine readable part, but you scroll down. As you know, each satellite, there's the orbiting body itself, right, that we're going to point at. But we have multiple transmitters on here. We call these transmitters or transponder satellite or so. It's of course these have a receiver on it as well. I'll note, because I don't think we've said this, that SatNOGS really is more on the receiving end. So we're collecting data. We have people, contributors and people doing SatNOGS that aren't licensed, aren't hams. So our community is wider than just amateurs, but a lot of people that get involved, they end up getting licensed because playing radio is pretty fun. All right, so each of these transmitters, if suddenly Fox 1A or AO85 grew an extra transmitter, you can suggest a transmitter. So if you click on suggest a transmitter, You'll see this.
I should note that those buttons will only show up if you are logged into the site. So if you want, logging in right now isn't as important for the demos as it will be in network, but if you were to log in with that account, you would see that suggest new transmitter.
Yeah. Yeah, if you're looking for it, you're just not logged in. So you can write a little text description, status fields of the status. Sometimes transponders will go off. Sometimes they'll be switching modes. The operator will switch modes, like the L-band uplink on the Fox. I don't operate it, so. All right, so active, inactive, invalid is just kind of a default there. It's a transmitter, transceiver, transponder, depending on what it is, and just some other data fields. The accuracy of this information just depends on who's doing it. So this is the part of it. Question, Bob?
Transponder as opposed to transceiver?
There's a long debate about that, and the definitions for each are in the wiki instructions for database classification. Yeah, the short is going to be mostly FM versus linear.
But not, like packet digitating would be a
Transceiver. You had one question here?
For the type of service, for AO85, it says service unknown. If I'm a member and logged in and say, oh, that's wrong,
Yep.
can just,
Yeah, absolutely. And in fact, that field was just added a month ago. So that's going to be unknown almost across the board because we haven't had time to go through and add it for everything else yet.
but a verified user can.
Yep, yep. And the idea here is to give more functionality for filtering and searching, especially through the API. Let's say you want only amateur radio service satellites, you'll get them, or weather satellites, you would just get those.
Earth observation, Earth exploration.
Yes.
All right. So mode is where, this field is where we key off to figure out which GNU radio script that we're going to run. So some of these are in here. So we have AFSK at different baud rates, weather, AM. Anybody doing AM?
On a satellite?
CW, right? You could decode with AM and hear it okay. We do have a CW decoder. Other sorts of things. These BPSK, different baud rates. You can see down here, there's another field for baud rate. So we have like a PSK receiver. The idea is that receiver you can plug in a different baud rate, and the GNU radio scripts are going to adapt to that new baud rate. We've tested it on satellites that are up there. So if there's a new one and it's a new baud rate, just a non-standard baud rate, then we've not tested it at those baud rates, right? So, all right. So if there's, do we come up with the extra fields if we go transponder?
Yeah. If you do select transponder, you'll have the ranges rather than the set frequency for uplink and downlink.
Set the bandwidths of the uplink and downlink. We do have the uplink, so this might be the documented uplink, and then if it's drifted, you can add in the frequency, and you see it's computing the drift in parts per billion if you want. If it's a transponder, you can see you can click invert if it's an inverting one, and then a URL for just documentation. You've seen on Wikipedia, there's the superscript that says citation needed. So if you got this information from somewhere, this is where that link goes so people can find more information. What that also does is when you make these suggestions for these edits, these edits are moderated, which makes sense because if this was just wide open, you make a mistake, now all of SatNOG's network is listening on the wrong frequency that's just incorrect. It's not like like cross-check that it's not a typo or something. So the moderation process is pretty fast. It's just a cross-check that, this is data that's being used live. If there's an error on in the transmitter itself that's configured, you can click on this button that looks like edit. It says suggest edits, and suggest an edit to an existing field if that is incorrect. This is where you would add, for the Fox series satellites, it says unknown right now. We can just set it to amateur and do that. This is the place in the website where, because we have satellites, multiple transmitters, some just have a single telemetry downlink or such. This one has more. But if each of these satellites has a unique identifier, if you hover over the I or the information button, if you click on it, it'll just copy it to your clipboard. But that string is the key in our database that identifies the transmitter itself. So you have identify the satellite, and then you identify which transmitter it is, and then that's how you can, say, do auto-scheduling. In our auto-scheduling script right now, you need that identifier so you can know which frequencies on this satellite you're going to listen to. This is where to find that information when you're collecting and figuring out which satellites you want to schedule and look at. Usually you're not typing in these identifiers, but this is for setting up kind of some more automated stuff that you're doing custom. Yeah, another question.
You can use SatNOGS to listen to the FM audio downlink from a ham bird.
So you can use...
Yes, we'll demonstrate that when we get into the network. The question was, we can use SatNOGS to listen to FM downlink of AMSATs. Yes.
Yep. We had the FM. If it defaults when you doing this through the website to the DUV. The DUV includes the FM audio. So, yeah. And it runs a decoder at the same time.
Yeah, that's the Fox satellites are pretty unique and pretty clever. If you're not familiar, the data telemetry stream is actually in the audible stream, the lower portion of the audible spectrum. So for us, anytime we want to schedule a Fox satellite, we want to schedule it as a data under voice mode because we're going to get both the FM output and the data from that.
So if you're working satellites and making contacts through satellites, you can schedule a pass that's going to be in the same footprint as you are, and you don't have to run a voice recorder if you're not one of those people that has 4 or 5 hands to operate portable satellites. All right, I'm going to scroll down just a little bit. So down here, this is a data decoding structure. We'll spend lots of time. The final portion of today is how to write these. It says click here, but this is not my...
Yeah, we'll save that surprise for the 4th hour.
Stick around.
You don't want to scare them.
Stick around. All right. All right, and these are telemetry frames, bags of bytes that have been decoded from the SatNOGS network. Click that, and you can download. I think it comes out as like a CSV file if you want to just look at that data yourself. Fox Telem also is AMSAT software that collects this data. What kind of cross do we have?
Nothing yet, but we've talked about the
Cross,
API, using the API.
Data,
yeah. In this case, you'll have the option of everything last week and last month as far as data goes. We need to tweak our algorithms a bit because we've got a little too much data for everything for some of these satellites. So everything might not work, but this kicks off a back-end process, and depending on how much data there is, it will email you once that link is available.
And it can't email you unless you're logged in, because then it knows your email.
Yep.
Okay. I think that's what we had for the database. So that's how to look at it. We have some statistics.
Stats, I think it's the.
All right. So it's in Python and Django. So just some statistics: 300 satellites, average of 2, 85% are alive, 46 million data frames. And if you scroll down, we have a leaderboard for the satellites. For data frames, these I know that these 2 Chinese satellites, that's a CW decoder that's on here. And those are actually
these high bit rate. Yeah. Yeah, we don't decode those through SatNOGS network today. They come from the DK3WN.
So does this filter out then the CW decoder?
Yeah, this is well, you know what?
Let's look at the code and see what it is.
It's this FSK 4800 baud.
That one.
So, well, what that is they are, if you look at some of the observations for that, it's a very high rate of frames, and so these users are doing the manual decoding process using the telemetry forwarder, and they're just decoding the 4800 baud streams, and it's just packet. So rather than some satellites, which are, a packet every minute or so. A lot of data come from those. So yeah, it's skews the numbers a bit.
So on the right side is a packet leaderboard, and this includes third-party uploaders from the DK3WN forwarder and such. So this is not just the decoding from the SatNOGS network. So if you ever wonder what these passes look like, so you click on CAS4A, takes you to the page that has the information about it, and then up in this right-hand corner, you see a live that is, to the best of our knowledge, this thing is functioning. When they deorbit, sometimes they stay alive in the network, and that means that nobody has just updated it yet. All right, so then if you want to see what observations just filtered on this one, you can click on that, go over to the network side, and you'll see all of the observations. The blue ones are future, and we can do more filtering that. We'll show you this bit in a few minutes.
You want,
Perhaps
you want
right
to jump into that now? Yeah. So, so let's click around here a bit. If you want to log into network, go to network.satnogs.org and take a minute to log in. I do have a slide. I'll go back to permissions in a second. Well, let me touch on permissions first. So when you first jump into the network, we have a permissions model that's a little bit progressive. We don't just allow new users to start scheduling observations across the network. That's going to be reserved for ground station owners and operators. So once you have a ground station online and once it's functioning, then you can schedule across the network. The demo account is one that's already set up and unlocked with these permissions. So that said, if you are following along with some of these demos, there are two ways you can go about it. First, you could use your own email address and your own account. If you set one up for SatNOGS, feel free to use that. If you don't have a ground station up on the network, it just means you won't be able to schedule an observation, and you could just watch us do it here. Or you could use the demo user that I handed out over the break and log in. The only difference there is you're not going to be able to set up a ground station under that user. So either way, or just kick back and watch the demo.
If you just want to pull it up, that URL is network.satnogs.org, if you didn't catch that earlier.
Yeah, so the login link is up at the top right. I am already logged in here, so if you're not logged in, you could go ahead and click there, log in, either, again, your user or the demo user. And yes? It is up for me. Let me do a hard refresh here. Yeah, it's up for me. So coming back from the link that brought us here from DB, if you want to, well, let's start over. I'll start at the home page here. You've just logged in. There are a couple of main places to go here. First would be the observations page, and then the ground stations view and the ground stations page. So let's start with observations. Let's browse through some pre-existing observations here. As Dan was starting to say, this is going to be the fire hose, and the fire hose is going to include observations that are scheduled out for the next 24 to 48 hours. So that's what you see in the blue items here. These are all, I would say the 22nd, these are all 24th of September. They're in the future. That doesn't tell us anything. We don't care about it. So this is where this button right here, see this button over here is a filter button. So if you hit that button, you'll have the ability to filter on status, the satellite, the person who requested that, the ground station itself. So we're going to unselect blue for future. We only care about what has already passed. The other statuses are going to be good. This means that somebody, either the system itself or a user, has vetted the observation as having something. Doesn't necessarily mean that that something was data or that something was decodable. It could have been something that was visible in the waterfall, but not strong enough to decode. That's still something. We have bad. This is going to change soon because bad has a bad connotation to it. It doesn't necessarily mean that it's bad for the ground station. It just means that there's nothing there. Unvetted is something that needs further attention by an operator to go in and say, yes, this is worth looking at, or this is something. And failed is just some issue. The Raspberry Pi didn't respond, or the RTL SDR didn't work. Something happened, and there was a malfunction. And that doesn't necessarily need to come with a bad connotation either. It's a good statistic to follow if we have a rising number of failures, for example. There might be something bigger going on.
For some of these vetted statuses, if there's a data decoder that's part of this transmitter, as part of the receive system, if we decode any frames from that pass gets automatically vetted as good. So the people doing the vetting is the ground station owner can vet the pass. That was in the permissions matrix, but clearly you ingested that whole big table and have it memorized by now. So the ground station owner can vet a pass. The person who scheduled the observation, the user that did that, which is it doesn't need to be the same thing, can also vet the pass, and then administrators can do whatever they want.
Yeah. So just starting off here, we'll unselect future, and we'll look at the fire hose without future observations. So we'll update filters.
I do have a question.
Yeah, go ahead.
I know you didn't fill them in. The start time and end time, are those UTC or are they?
Yes. Yeah, it's all going to be UTC, and we've thrown a UTC clock up here in the header, so to give you a little bit of a reference.
What did you just click?
So I came from unselecting future and then update filters. So if you update filters, now you get a view that is darn near real time. But as Dan mentioned earlier, the data sometimes is going to lag a little bit as the Raspberry Pi has to process the waterfall and then upload all of the data. So like this observation is still ongoing, or just finished a minute and a half ago. So there are no results here. You see these little icons. They're going to represent a waterfall has been uploaded, audio has been uploaded, and then data has been uploaded. So let's scroll down to, well, here's one with a data, and it's a NOAA satellite. So this is APT imagery from a NOAA satellite that was automatically decoded. So if we click on this, you're going to see the observation page. Now this is going to give you all kinds of information, the satellite, the ground station, who requested it, what the mode is, what the frequency, time frame, what the orbital parameters for it were, as well as metadata for the client, or from the client, I should say, to look at. We also store, that's accessible, down here and through the API, we store the actual TLE that was used for that observation so that we can go back in time and recreate the orbital parameters for what an observation looked like. And I'll go in, at the very end, I'll go into why that's important to citizen science.
Those are really cool plots.
So this, you can see the waterfall. I don't know, this station is in the 900s, so I think it's very new.
Question?
Yeah, so that's a nice straight waterfall, and that's because that receiver was tracking the Doppler, and so therefore.
Yes. So the Raspberry Pi is doing all of the Doppler correction in real time, and I think around 10 times a second, 10 adjustments a second or more. In fact, you can see in this waterfall, you can see that everything is nice and corrected for, and you can see some of what would be terrestrial or ground noise beside being shifted.
One more question about
Yeah.
if you're, so apparently your software and SBR software is smart enough so that when it does a Doppler shift of the receive frequency, somehow it does not phase screw up the data. In other words, a lot of satellite operators are running Doppler correction and they don't decode anything because every time the radio steps, there's a phase transition in the receiver and you just lost.
Yeah, the question is in the resolution of the Doppler shifting versus not being able to decode because of changing the phase. Yeah, I'll show a glimpse into the GNU radio scripts in the 4th section and kind of go into what that looks like. That is still a problem today for our CW modes. So we have a CW decoder that's in development right now, and we're not quite adjusting the Doppler quick enough to stay on target there for CW. Next question. What's that?
The data, that was
So in this case, the data is here in this data tab.
I'll talk just about the Doppler stuff. So the Doppler correction that SatNOGS is doing, this is happening on the client, and maybe it's 100 milliseconds right now that we're updating this in GNU Radio. But this is a forward prediction only. There's no feedback in this. So this is open loop. This is predicted as if the TLE was correct.
Yep.
So it's only good as your elements.
Yeah, it's not locking the signal per se and then tracking the signal itself. It's tracking to the TLE. Mm-hmm. So in this case, the data component of a NOAA satellite is just going to be the APT imagery. And this one, it's not too great of a copy, but you can kind of see where what that would look like.
If you have a better decoder for the APT images, you can go to the audio side and get the baseband version, pipe that, download the audio, pipe it through your decoder. I know there's some commercial APT decoders, and you can get a better image.
Yeah, and that audio is down here at the bottom. You could do it two ways. There's a link down here at the bottom for audio downloads, or you can play it straight from the browser with this audio tab. So we'll try, and you can see a little bit of a spectrum below where that signal is. So we'll grab a couple of others here. Let's go back to observations, and we'll filter on.
Did we talk about seeds? So there was a lightning talk, I think it was yesterday, about the Dwingaloo telescope.
Oh, I've got that later.
Yeah, so.
Yeah, we'll get into that.
I'll keep my mouth shut for now.
So yeah, he's a great contributor. So let's look for something that's the Fox satellites have been mentioned. Let's pick one. So in this case, we're going to search on a specific satellite. I will search on my specific ground station. And I should have unselected future, but there are none. And in this case, you can see these are all passed. A couple days ago, the observer, in this case I was testing the demo user on my own station. Someone else has been watching the Fox satellite. And like we said earlier, in the Fox satellites, this is a little special because they have that data under voice. So if we pull one up, you can see what this looks like on the waterfall, and see the plot there. Data-wise, this is what those data frames are going to look like. By default, we show them in hex, and we also have in this case, the ASCII decoder isn't going to give us anything, so that's fine. But this is the actual hex data that then gets passed on to the database site that we saw earlier, and then eventually gets decoded into telemetry figures for the dashboard. So in this case, we decoded 75 frames of data, which happened underneath the audio of the QSOs that were going on at the time. I assume they looked like it on the waterfall. So pull up the audio here, and we can try to listen in. It's a rough copy. So to answer your question, yes, we can listen to the Fox satellites, the FM satellites. We don't currently have a good way of tracking or listening in and decoding the linear birds, just because that's such a spectrum. But we do try to get telemetry data off of them. Let me go back to observations. So another one, I will show an ASCII example. Let's go to, what is the name of the armadillo, I think? Yeah, so if you want to search for armadillo, we'll take off future, any station, and in this case, I want to look at the data frames from armadillo. So for this, I'm going to use a results filter with data. And of course, the deselecting the future really doesn't matter because I'm only looking for data here. Here's some passes with data. Let's take a look at these. And these are a much higher speed. This is 19.2K in these bursts. You can see them. In this observation, you can clearly see the Doppler correction by the terrestrial noise being shifted as it goes down. So while everything else, these actual packets are the same. In this case, this is going to be a risky click. There we go. Armadillo has some fun little Easter eggs in their downlink packets, so it's always fun to watch and see what it's going to say next. Yeah.
It's fun.
So,
if you're a satellite operator and you want to get engagement from like other people and get them excited, this is a wonderful way to do it, isn't it? Right? You get so deep in the technical thing, and just make it fun. Add some random text generator.
But it's mandatory that you play Portal 2.
yes, good. Get the references. So now we've got browsing observations down, and assuming we have time at the end, I've got some more Easter eggs to share. But you could spend days and weeks just browsing in and looking at this data and looking at the differences across data. If you see something interesting that is noteworthy of discussion for one reason or another, and you're logged in, you can hit this discuss button, and this automatically opens a forum post in our discourse site linked to this observation. So now we've got this post coming up regarding observation 998.198. Hey, armadillo is saying something cute. Post it and start a conversation. This link right here, discuss.
Like you might be looking at an observation from your own station. That's a time that we see this. or that you would use this. You can do this for any observation, but you want to talk about it, and you want to make a forum post and ask a question about, and reference something that you're talking about specifically. This automatically drops the link to this observation in your forum post.
Yep.
So it kind of fills out a template so you can say, hey, I see this signal at about 300 seconds. What's going on here?
Yeah.
So this is a way to draw attention in the community to something, I mean, hopefully worthwhile, but this is a way to basically put it out there and say, I think this is something, not maybe messages like this, but draw community attention to something.
Yes.
With a context to it other than the generic thing.
Yeah, absolutely. This is a way to tie something noteworthy into a conversation, and start a conversation about something noteworthy. Otherwise, we're swimming through, thousands of observations a day, and so not everyone is sitting there looking at them all. I'm not. It's just not feasible. So and the discuss is only going to show up, I think, if you're logged in. So if you're not seeing that button, it might be because you're not logged in.
What's this one? I teach power electronics.
Oh,
And we burn up stuff on the first day.
So this is vetting hotkeys. So let me get into this after we schedule, because I'll show how to vet. But let's take another step back and start from a new user perspective. So you've just logged in. You can go to your dashboard under your little icon here. And if you look at the dashboard under the demo user, there are no ground stations listed for the demo user. So let's say you've got your Pi, you're ready to set up. You need the API key for your Pi. That's going to be under this link right here. If you click it under the demo user, you'll see an API for the demo user right now. I'm not going to click this and expose mine to YouTube.
Just do it.
Nope. So
It's just a long string that you copy paste into the client on the Raspberry Pi, the command line, and it came up with the menu system. That's where that string goes. That's how to see your key, and that's your credentials from the.
So once you copy that API key, we're also going to add a ground station to match the Pi, and this is the network's representation of what your Raspberry Pi is. So we'll give it a name, TAPR demo description if you would like. I believe we support Markdown, and latitude, longitude, altitude. We automatically calculate the QTH. Grid square of that. You can throw an image up of your ground station if you want, or not. And this is the minimum horizon for that ground station. Again, going back to obstacles that may be in the way around you, or if you have some kind of Yagi that's pointing just straight up. Target utilization is not quite implemented today, but if you wanted to limit the utilization of your ground station, this is how it's programmatically done. And then antennas. There are a couple that are in here for development and testing, like HF dipole goes from 29 to gigahertz. That's not really an HF dipole, but this is a good one for testing just random stuff, and you want the entire spectrum of frequencies. Otherwise, you might select VHF, UHF, and the frequency ranges are going to be here. If you wanted to include the weather frequency ranges, there's an entry for this VHF Yagi here, or not, and the network will schedule appropriately.
Yeah.
Have you thought about sectoring that horizon so that you could have more information than just...
Yeah, the question, have we thought about sectoring the horizon and stuff? Yeah, there's a feature request in our GitLab for being able to calculate blind spots and maximum horizon versus minimum horizon. Yeah.
Yeah, next question.
Why would you want to limit your utilization or have a target utilization? Keep the bearings from wearing out?
Yeah, so sometimes it could be to keep your rotator from wearing out. Another reason could be if you have this at home and you're on like a DSL line, you know that your uplink is abysmal. That's the A for ADSL, right? So each observation, the audio upload, or the amount of data is maybe 25 megabytes per observation. And if you're just running observations back to back to back, you may saturate your home internet uplink. And if you make the rest of the family
yeah, across the community, we've got the entire spectrum of users who are looking into how can we just send all the IQ data and what can we do with that, all the way to, a ground station is going to be in Antarctica and have a satellite uplink, which is a little bit ironic, but a limited budget, and how do we work with that? So,
Are you using lossless compression or anything?
Question is, are we using lossless compression? We're using Ogg Vorbis, and it is not lossless. I will also attest that taking the audio files from some of these observations and running them manually on your computer through other decoders, like the high-speed sound modem from UZ7HO, will work just as well. In fact, in many cases, will work better than our own decoders. So yeah, if you have an observation and it looks good and it looks like you've got data there and nothing's working, but you want to see if there's still valuable data in those packets, download the audio file and run it locally.
Do you have any instrumentation on your Doppler correction so you can evaluate the performance?
The question is, instrumentation on the Doppler corrections, we can evaluate performance. No, but we're working on that. Instead of generating Doppler corrected images, we would generate just the data for the waterfall and then be able to adjust for Doppler or not in the images. So yeah, lots of experimentation in that realm. One of our community members has some scripts to be able to do some kind of analysis of Doppler correction and satellite identification based on non-Doppler corrected observations from his ground station.
But at the moment, you're not trying to get better TLEs from this data?
That's why he's doing that, is to, especially, so new satellite launches happen and you're either given a preliminary TLE, which is a good guess, or it may be launched from the ISS and you're relying on the ISS TLE, which is only going to be good for a few days before things start to drift. And we will notice that drift on our observations pretty quickly. But we also have satellite enthusiasts in our community who are quick to try and discover and identify which satellites are which. And if you're into that, jump into our forums and get on board with that too.
Before we leave this page, the antenna configuration here, there's the tag, there's the name for the tag. Sure, that's important, but that's more of a human thing to maybe filter on. The most important part is that the frequency range includes the bands that you're interested on scheduling on your station, because this is a default filter. You won't see observations or predicted passes show up for a certain ground station if it's not configured for an antenna for that band. So if you don't have an antenna, it just won't show you it. If you're playing around with antennas, you'll need to go in and change your antenna setting for that station so you don't filter those out right away.
Yeah. And the last thing here is the testing flag. On a brand new station, this testing flag is enforced because how do you know it's good on your first shot, your first observation? So after you've had a couple of observations and you think it's great and it's performing well, unclick this testing flag and you are off and running. So now, let's say you have a ground station. You can see that ground station underneath the dashboards page, again, under your icon there. Or you can go to the ground stations page and go to find your ground station specifically.
You can hover over the color. The color green means it's online. Any other user can schedule on this. Orange is only you can schedule on that. We call that testing mode. Red means the network has not seen this ground station and it's timed out, so it's just flagged as offline. And if you hold the pop-up says seen so many minutes ago.
Yeah. So another thing, if I go into this, one of my experimental stations, this happens to be configured with the Raspberry Pi over here. An important note is your ground station location information is only going to be as good as you make it. So if you have a set of coordinates in the network or a set of coordinates in the Raspberry Pi that are wrong or that move or that change over time, they have to be manually updated. Otherwise, you will see a bit of a Doppler shift compared to what the system thinks it is. So in this case, right now, the system thinks that this Raspberry Pi is in Indiana, whereas here it is in Michigan, yes. Mm-hmm. We are working on, there are people working on connecting GPS to the Pi, different GPS systems, so that it auto-updates. We don't have it auto-updating in the code quite yet, though. So what had happened here, when I brought up this station page, you will notice at the bottom, especially if you have a wide range of antennas, this may take a while, but you will have pass predictions for the next 24 hours. What this is this is going to calculate everything that's going to pass overhead that is within your parameters set for the station. In this case, in the last setup, I was trying to replicate the idea of a Yagi sticking straight up with a high horizon. So my minimum horizon was 40 degrees for a pass, and only UHF. So all we are going to see here are satellites that are downlinking in UHF with those orbital parameters. The colors here are success rates in the past for that specific satellite, not necessarily tied to your ground stations. So this one, is probably not very operational or functional. It hasn't been very successful in the past, whereas this has been. So I can come down here. I can schedule an observation from this perspective. Let's see if
all these times are in
Oscar
UTC.
7.
If you're like me, then you schedule a whole bunch, and then you come back and you start hitting F5, and you realize that you're 5 hours too early.
And anytime you see this blue icon, there are hotkeys. There are some of our users and operators who are scheduling stuff every day, all day, and so those hotkeys become really valuable to them. In this case, this opens up a new page for a new observation. If there were different transmitters, I could select which one I care about here. It's already selected my station and the time frame for me, since that was already pre-calculated. So all I have to do, and again, if I want the orbital parameters, it'll pop up there, is hit schedule. And it's done. So within the next minute, the Pi will check in to the network. The network is going to say, here's an observation for you. Here's the dates, the frequency, the mode, the current TLE. And once that's all done, the Pi will return everything back to the network. There's another way you can go about scheduling an observation. If we go to the observations page.
Is there a question about the?
Oh, sorry.
Just thinking, it's a minor UI thing, but why don't you have an option to go to the local time so the ordinary?
I think there's actually a feature for that a feature filed for that in GitLab. Yeah. For just looking for developers, and for you students out there who are looking for experience in CS and coding, we need lots of coding help. And there are lots of opportunities like that one to, say come up here and click. Actually, no, that just brings up time world clock. That doesn't help. There you go. Yeah, look it up.
It does cause lots of errors operationally. You want to be dealing with one time at a time, whatever your choice is. If you're not thinking in UTC.
Yeah, that's hard if you're not already in UTC in your head.
But you want to have all your everything recorded that way, but it's
right. Yeah, and that's a simple UI thing. It just hasn't been coded. Bob.
Is it just me, or whenever I see something in local, I just don't trust it? Somebody else has made a determination of where they think I am and where they think I'm serving, and it's my computer, or is it just me? Most
So if we make it configurable, everything under the hood is always in UTC. So the user interface, the part that we would make sure that the user interface, that when you schedule observations, it looks like local time from the display side, but it's really pure UTC the whole time. So if you wanted...
I feel your pain, Bob. I work for a company that where most of my coworkers don't realize that there's anything outside of Pacific time zone. So yeah, that's a thing. So all right, observations. There's another way of scheduling new observations. That's coming to the observations page and clicking new observation. Again, there's some hotkeys here, but selecting the satellite. Bob was talking yesterday about BisonSat coming back to life, possibly. So, oh, BrickSat, yes, BrickSat 2. Thank you. So we're going to pull BrickSat 2 up, and Bob was interested in the 9600 baud downstream. So we're going to select that. Immediately, we could filter on stations if we want to, and select specific stations here. Selecting some time frames, let's say, the next 6 hours or so, and calculate this. We might not get too much because typically things are pretty busy and already scheduled. So for the next 6 hours, yeah, that's a good amount. So from your perspective, you're probably not going to see what's down here at the bottom. These are testing, and I've got rights to see that. But here we have all of the available stations with that frequency range capability that satellite is going to pass over in that time frame.
On the horizontal axis is time.
Yes.
And then each of the boxes, the width of the box is the time.
Yeah, you can see the time down here if I scroll down to the bottom. And each one of these, you could hover over and see, like the plot for this observation, 4 degrees is not, so let's not bother with that. Let's change the max elevation. Let's set that at 10. Filter some of those out. So now we've got a subset of that. All we got to do is hit schedule. That's what you get for live demos. Try that again.
Are you correcting for radio horizon? The radio horizon at that frequency?
Are we correcting for radio horizon? That's a setting in the orbital predictor. Right now we're using PiFM, and you can configure that. I don't remember exactly what we do. UHF, it's not by much. It's going to be within your beam width, so we've not many of our stations have a narrow enough beam width to make that be a significant difference. It would change it by a few minutes, yes.
So the reason that error came up is last night after Bob and I spoke about this satellite, I went and scheduled a lot of those. So there's already a lot of overlap for that satellite there. So let's go a day out and try this again.
Did you have a question?
Well, he's answering. Okay. And there we go. 20 observations scheduled. So now that's going to run, and as they pass by and as they collect their observations, I can go back and filter now. I can look at myself as an observer, looking at all of these. Here, let's update the filters. And now I can see all of these observations that I just scheduled, as well as going into yesterday's. And unfortunately, I'm not seeing any data decoded from yesterday.
I'm looking at one that occurred at, it wasn't yesterday, 09/22. That's too hard to go look at on your station.
Oh yeah. There's something on the waterfall there. So if I go to
09/22
0922.
11:37.
Oh, 1137. Yeah, sorry. All right.
That one.
This one or? Yeah.
Oh, I'm sorry, it's station 411. That's not.
Yep. This one?
Yeah, now, could that possibly be 9,600 baud packets and then a gap, or 9,600 baud packets and then a gap, or is that just?
That looks a little wide for that. It's probably noise.
Okay, thank you. That's the
If
only one I found that had anything in it.
the one I just had, I think it was right here.
This has a rotator on it, and the motor and motor drivers aren't shielded. This will leak in, and you might see
These
RFI.
look like they're Doppler corrected, right here in the center. They look like they're probably packets, but we didn't decode it. Yeah, like this right in. And here's another one up here, and another one down here. So this is one where, in your case, I would take the audio from this, download this, pipe the audio through UZ7HO high-speed modem, and see if that decoder can actually decode it as well. Yeah.
So I thought you were going to answer this, but maybe I didn't understand. The overlap that it was complaining about, was that because another station had, when you were trying to schedule the stuff at a particular station, there was already an observation for the same satellite?
The question is asking about overlaps. There was an error that showed up.
I think that's one that I don't run into often. I think that there was a conflict with either the observations I had already scheduled or something that got scheduled between clicking that and then clicking submit.
Okay, that was
Yeah.
what I was wondering.
Yeah.
Was there so much?
Because there are a lot of people on here right now. Yeah. Otherwise, it's pretty safe to just go on and schedule. When they're all done, you get in the user interface. You will, if you're scheduling observations, you'll see this little icon up at the top right. These are observations that need vetting that you scheduled. So this is your to-do list. Go in and clean up after yourself and vet your observations here. All this does is links to a special filter under our observations page, and you can go in, and since I scheduled all of these within the last day, I need to go through and vet them. And if I go back to the one we were just at, sorry, I'm clicking around. This right here, was this it? No, CA, here it was. Okay, so vetting. So here I've got something that's not vetted by the system because there was no data uploaded, but I have gone in and I've visually verified that yes, there is something there that's Doppler corrected, at least on the waterfall. So I'm going to vet this as good. Click this as good. Done. There are hotkeys for doing this as well because if you go back into your NAG list of work to do and observations to vet, you can scroll down to the bottom and hit one button here and it will open up everything in tabs. So yes, opening 50 tabs all at once. As a Mozilla employee, it makes my hair stand. But it works, and then you can just go from tab to tab and use the hotkeys and quickly vet observations.
After doing this for a while, you can identify the satellite from the waterfall. After you've been looking at these, you can say, oh, this is Fox 1A, or this one is who knows what. You can see that on the left side, but after you do it for a while, especially with the hotkeys, you just look at it, you say, that's good, that's not signal, that's interference.
Yes.
It's still like the Matrix, yeah.
So, going back to, yeah.
On the scheduling, you picked a time and basically capability on the antennas, and it shows you everything that's available. It doesn't filter out overlap on stations, is that correct?
The question.
If you have 5 stations within the same time period that are going to see the signal, it's not going to filter that out.
It should filter out overlap. And from the station perspective, it will show you the overlap on the past predictions. And I could show this. Yeah, let me go back to that and show this.
The overlap that are an issue is all of these stations, all of these observations are single channel. So when a station is doing an observation, it can't do anything else. So that's the only overlap that would cause an error. You would have 2 passes, a pass here for one satellite, a pass here for another satellite. They're both in range at the same time or overhead at the same time. And then you would just need to schedule those observations, truncate the timing of one or the other so that they're just not at the same time. Overlaps between same satellite, satellites in the footprint of multiple ground stations, that's no problem at all.
I was just going to go a clearer way to say that is a single station can only listen to a single satellite at once, but as many stations as one can listen to one satellite at once.
Yes. Yeah.
We need a microphone.
Yeah, and you can, and there are some users, like for example, for my ground station, I have VHF and UHF on a rotator, ASL rotator. It's not going to make sense for me to try to listen to one satellite that I'm pointing to on VHF here while a UHF satellite is over there. So I am only going to be capable of one at a time. We have some ground station operators who run a station on VHF and a station on UHF, and they just run 2 different PIs to 2 different antennas, and they can be run simultaneously. So the overlap problem here too, this past predictions is going to take a while because I've got both UHF and VHF, but once it loads, you'll see all of the observations that are possible across my ground station with some overlap display here. So for example, these are gray, if you can tell here, versus white. The gray has some kind of overlap, and it tells you what the overlap is. 100% overlap just tells me that this observation has been scheduled. So I can go down, schedule some more, see if there's any other overlap. Yeah, there's another one that's been scheduled. So from the station view, it's very obvious, but from the scheduling view, it's not.
If you look at the times, you're in UTC, you see that there's a pass coming up. It's coming up in 2 minutes. Some of these schedule links on the right side, they're grayed out. Some of those first ones, just in the interface, we gray out those because if you schedule something on the network and your PI hasn't checked in before that observation is scheduled to start, your PI just won't see that observation until it's too late. Yeah. So if you're impatient, there's like a 5 minute into the future, 5 or something minute into the future that's grayed out. And really that's just to give your PI time to check in with the network so it can get the observations that are scheduled for it. It's not, these aren't push observations where you schedule it and it makes contact with your PI. This is really a polling sort of system.
Okay, so let's move on to dashboard. If you want to participate in this exercise, go ahead and log into dashboard.satnogs.org, either using the demo account or your own account if you have one, and we'll take a 10-minute break and I will bump privileges on those accounts, or just use the demo account, log in. This is also a good point to note that in SatNOGS we have single sign-on, so one account will work across all of our applications with the same authentication. So once you hit that, where that arrow is, to that sign-in box, that will get you in. Where the big red arrow right here, this little sign-in.
You'd be looking on the upper right side, but this page, it's on the
this one's different. This is not an application that we wrote. This is something that we pulled off the shelf.
I remember some conversation in a forum post. I don't remember what the context was, but the single sign-on, You've seen this around. You can log in with your Google account and such. This single sign-on system is not attached to Google. So this is like just within Libre space stuff. So it is single sign-on. It's the same technologies, but it's not, you're welcome to use your Google email, but it's not, it's a separate system. Same technology, but not administered by others.
Yeah, so I think we're a little behind on where I would like to be, so 5-minute break or however long it'll take me to bump these privileges, and we'll get started on section 3. All right, we're good. Okay, so section 3 in SatNOGS tutorials and demos here, we're going to get into some of the back-end stuff, the APIs, some of the contributing guidelines. We're going to start off, though, we left off with using the database, using the network. We're going to get a little bit dirtier this next couple of hours. Just so I can get a feel, how many of you have familiarity with a programming language? Okay. All right. So you should be fine. How many familiar with database queries of some kind? Okay, good. So I'm going to go a little bit quick so that we can get hopefully to the end in the next hour and 22 minutes. Bear with me. We'll start in the dashboards. So let's, for those of you who have logged into the dashboard, I will show you a couple things real quick. Everyone else can just sit back and watch. Get back to our demo. Okay, so if, let me bump this up. This is probably going to look a little different on your screen. I've zoomed in a lot to hopefully catch the back row. If you log in and go into the dashboard, you don't have to log in to use the dashboard or to see the data in the dashboard. Any of the dashboards that have been publicly published are going to be available openly without login. So that is going to be some of these stable dashboards. We still have some that we consider a work in progress that are here, and you can click on them and take a look. Light Sail 2 is a popular one, so we'll start here. We'll click on the Light Sail 2 dashboard to see what it looks like. These dashboards are crowdsourced, just like everything else in this project. So one of our contributors has gone in. They've figured out the telemetry format for Light Sail. We've written a decoder for it. And then once we have that data in our database, they've pulled up this dashboard and designed this dashboard for that data. So no two dashboards are going to look the same. They might be very satellite specific or very use case specific. And a dashboard does not have to necessarily be specific to a satellite. There are a lot of satellites up there that may be copies of one another, and it's beneficial to see a dashboard comparing two satellites, or in the case of the Foxes, all Foxes.
Since this is going to be recorded, we don't have many spacecraft operators here, but you can make a dashboard for your own satellite. I know Bob was talking about yesterday that he doesn't even run a ground station because the APRS network already does this. So if you're operating a satellite, you can see these almost real-time dashboards within 15 minutes or so once everything gets uploaded to the network. And you don't have to spend developer time, if this is the capabilities that you need, writing it in here, as we'll show you how to do that. Now you can spend your time doing other engineering or doing other operations that is actually important to you.
Yeah, and we love working with satellite operators and satellite operator teams coming in and creating their own dashboards. We do have quite a few that are working with us now. So here, I picked this one at random. You can see, the frame count since last reboot, last frame. This is going to be in UTC. Last frame received by, I swear I didn't plan that. And this is all going to be based on the time frame that is in the upper right corner. So this is really important. If you look at a dashboard and you see no data, well, then there's no data for that time frame. You might have to zoom out a bit. You might have to change your time frame. If we want to look at the last 30 days, or, light sail hasn't been up there all that long, so let's go 90 days. This is the frame count. This is when they deployed the solar sail. That's a flag that comes down in telemetry, and as you can see, not all data is perfect. So, something came back with a 0, and we've got imperfections in the system, but that's okay. That's a chance for improvement. Yeah.
So the vertical axis there is really 0 or 1?
Yes. Yeah, in that case, that was their telemetry bit for solar sail deployed. It's binary. So in this case, I'll show you in a minute, this doesn't have to be a graph. It could be, a status, which is where this comes into play. So what this is an object within Grafana that works on that binary bit and says deployed or not. So some of the things you can do, I'm going to brief over all this and let you go home and dive into some of these dashboards on your own. For those who are logged in, if you go to Manage, under Dashboards, there are some more under a couple of folders that we call Scratchpad. And there's also this AX25 monitor that I personally like. I don't know why we have this on the main page. But anything that we're doing AX25 decoding on, you can pick from up here using the NORAD ID. Here we have FalconSat selected, and these are all the FalconSat messages. But anyway, that's a tangent. If you go to Manage and Scratchpad, these are various work in progress dashboards that people are working on and playing around with. You can go in, you can grab a dashboard, you can make a copy of it and hack on it on your own. For the sake of this exercise, we'll show you how these are made by clicking New Dashboard. So those who want to follow along can go from that sandbox to click New Dashboard. Initial users, we only put them in the sandbox access at first until you get some familiarity with the system. So in this, this is a front end to the InfluxDB that we have running, which is just a simple time series database. I shouldn't say simple, it's very complex, but this makes it simple in that we're going to build a query from this user interface. So we're going to add a query. We've used Unisat 6 in a couple of examples, and I'll use it in the Kaitai example later on just because it's very simple from a telemetry format perspective. So if you can imagine every satellite as a measurement in the database, not the telemetry figures, but every satellite as a measurement, we tag them by their NORAD ID. So Unisat 6 is 40,012. So we're going to select measurement 40012. And keep in mind, as we do this, that what the default time frame is. So we're looking at last 6 hours. That's going to become important here in a bit. You can further define this query by other metadata tags, by the station, or did it come from SatNOGS, or did it come from the SIDS endpoint or whatnot. We're just going to leave that for now. We want all measurements for this satellite. And then from within that measurement, each time we get a telemetry packet, that is one packet full of fields for all of the telemetry. So we're going to select the field. And in this case, to make this simple, I'm going to look for uptime. And I have to scroll a lot since U is at the end. So field uptime, and right away it's building this graph in real time. You can see already we have some data on the graph. Bob?
When you selected that
Yes, yes. Yeah, so if I change this to 25544, which is ISS, suddenly all of these options change. Yeah.
The next section is how to get those options in there, and we'll show you.
Yeah.
That's a cool part.
Yes. So we're going to go back uptime for that. We don't want the mean for the uptime. We're going to just remove that and instead let's go distinct. We're not going to average it out or anything. We actually want the actual uptimes that are being given. So now we've got a little bit of a graph. There's some blanks here, so let's and you have to wonder if is this really right? Does this look right? So let's go over the last week, or not this week. Sorry, last 7 days. This week just started. So last 7 days, you can see, you can measure this in a multitude of different ways. Okay, this looks about right. It looks about like a satellite uptime graph does. There are reboots, there are things that happen in space, and satellites reboot. So that seems normal, but here we've got 400, 300, 100 million. What does that mean? Well, the uptime is given to us in milliseconds. So what we've got to do is, if you click on the visualizations, over here on the left, here we've got a graph visualization. We could change this, but we're going to leave it graph for now because we want to graph this. You scroll down to the axes, and under unit, by default, it's just going to give it a number and use the number that it's getting. So we're going to select that and scroll all the way down to time. There are all kinds of different units that are built into this tool that you could use to measure a number. But we're going to go to time and milliseconds. And if I'm right, there we go. Now the axis is correct. It's right. It's showing days, and if we were to hover on this, it will actually show us that point in time correctly formatted to what the value is to an actual user. So that's how easy it was to go from a bunch of numbers in a time series database to a readable graph for an end user. And we can go, let's 7 days. Is this reboot cycle normal for this satellite? I don't know. Let's take a look.
You selected milliseconds and yet it displayed in days. Did somewhere else you say I want days, or does this thing just says days is more appropriate?
Yes. Yeah. It's a format of time. So it's a human readable format is why we selected that.
But you selected milliseconds. Where did you select it?
So I'm telling the graph system that the measurement is in milliseconds. So where to go? Yeah. So in the units, I'm telling it that the unit is in milliseconds because that's what the satellite is giving. So it formats it as a human readable days. And here it looks like a couple of errors.
It does a reasonable.
Yeah, it's automatic.
Hopefully it's a reasonable scaling on your axes. So many milliseconds that we're not going to use scientific notation for milliseconds. We're just going to say 6 days.
Yeah. So that is that. If we go to this general settings icon here, let's change the title of this to uptime. Then we can go back to our dashboard, and now we have this graph. So let's add one more thing for this demo and move on because there's so much more. So we're going to add another query. So here we are selecting a measurement. Again, the satellite 40012. But if you're thinking about this is where you could start to add different satellites or even combine queries. You see this letter A here. This is just a single query for this graph, you can add multiple queries, you can combine, you can select, all kinds of stuff. We're just going to scratch the surface here. For the field, let's look at packet index. And again, we're going to remove that mean. All I want is what the current index for the packet is. Let's just say that the very last packet that we got, what was its index, and we're going to show it as a field, not a graph. So for selectors, we're going to go to selectors and select last. And so I'm going to try to graph it because that's what it does. We are going to go into the visualization, change this to single stat. And that's still not right. That's not the right, I don't think that's a correct packet index given the reboot counts and everything for the satellite, just because I'm familiar with it. So I think average, current is what we want. So we're going to change that to current instead of average. And now suddenly we have the index of the last point in time in which we got a frame from the network. So last step, settings, we're going to say packet index. And this is all clicky, draggy, droppy. You can move it over here, you can move it there, and start to add more for the satellite.
Can you, Corey, can you update these dashboards or make a new dashboard for a satellite even if you're not operating a ground station?
Yeah, we would love to have more Grafana contributors. And this is one of the ways in which, if you're in an apartment, you want to get into this stuff, but you can't put an antenna up, get in touch with us. We need all the help we can get with this stuff. This system is new as of first of the year. So we don't have a lot of graphs or a lot of dashboards for the satellites that we're actually tracking because they haven't been built yet. So we're looking for people to get involved.
And as you know, some people that are good at graphic design are not good at RF, and those people that are good at RF and Linux are abysmal at graphic design. Case in point, TAPR website. It's like, right? Because TAPR is better at other stuff, and there was a call, right? The member meetings, like, please help us out.
Yeah.
So can there be multiple dashboards that have been created? And then I guess my question is there a way to vote, like on Stack Overflow, and you can vote on the best answer?
So is the ability for multiple dashboards there, and can you vote on the one? Yes, there is. There are multiple. If you go into the Scratchpad, you'll see like a bunch of different, Fox satellite dashboards as we were playing around with different things. Is there ability to vote on one? No, it's mostly a discussion that we have in our chat rooms or forums, because there really aren't that many people doing the graphs today. But I like where that's going because at some point in time, these graphs are going to have to get integrated into the satellite pages themselves, and we're going to have to figure out which one makes sense. So let's dive quickly into the APIs. This is going to be a quick section for those of you who are familiar with APIs. In the SatNOGS DB and the SatNOGS network, we use Python and the Django framework. There's a package for that called the Django REST framework that provides APIs that are a bit self-documenting, if you will, and easy to follow from a human perspective. So we go to, I know it's not easy to see up here, db.satnogs.org/API. You will see a representation of the API, and these are actually clickable. So you can browse the API yourself as a human with a browser and figure out what you're looking for, what you need as you're building applications that may use these APIs.
If you're taking notes, just remember that we don't currently have a link to this page from the web pages.
Right.
So but all you have to do is type /API at the end, and that's how you get there. So if you forget to type the /API, you won't find it. So it's a
So if you want like the list of satellites that's in the database, you could click satellites. This is what it's going to look like to another computer system, all formatted in JSON. In fact, if you wanted the raw JSON, you can click this to get the raw data. Well, Firefox is going to format it for me. But you get the basic idea. If you're interested in the API, just go to /API, browse through it yourself. We are working on possibly some other API doc formatters that build better documentation out of the doc strings that are in the code. But for now, you can click around. This is where you could also get the fire hose of telemetry.
Do you have versioning on the API?
1.0. Not yet, no. Eventually, yeah. And the problem here is there's the API for the database and the API for network. So we want to figure out what's going to make sense for versioning without, while they're on different development streams, while still trying to tie them together so we're not confusing developers too much. But right now, the changes are so few that we haven't started versioning them, but we're going to need to before the next big change. Yeah. As you can see, this is automatically paginated by default as well within the API. Otherwise, 1.8 million pages would be a lot of data to show here. But this is where you could actually go in and build queries through the API for a specific satellite and get the frames that we've collected. So here's a frame NORAD 40909. I don't even know what that is. So, whoops. We'll look it up. Just because I'm curious, 40909. XW2E. And here's the actual data frame. So you could pull that out programmatically and run it through a telemetry decoder, or using our decoders, we actually have some helper scripts that will pull frames down for you as well.
If you already have a dashboard, you don't need the Grafana dashboard. This is how you can get the data from SatNOGS and pipe it into your own dashboard. This is where it's how you get it.
Yep. So we go to the network API. It's going to look very similar, only you're pulling from a different source and a different type of data. This is where the SatNOGS clients are getting all of their information. So you're going to have things like jobs. This is where the client is going to check in once a minute and ask for the jobs for that specific client using a query string. Whereas if we click on it, we're just going to get the fire hose and see. So again, you can see this is where the network is going to give the client the ID for the observation, start, end, the TLE, the frequency, the mode, and the transmitter and baud rate.
Was there a question?
I was just asking, how scalable is your infrastructure?
How scalable is the infrastructure? I hit the public APIs. That's how I generate my plots. So I'm hoping to contribute to the making it more scalable as I hit the API more often. I don't know.
Yeah. It is today, and we've had to migrate to bigger and better infrastructure our last couple of years, and I know that our next migration is going to be into a multi-container orchestrated framework. As we did our last migration, it was into containers, so that the next step is just going to be even easier. So that's the API on the network. Again, stations, we can look at the full fire hose of station data in here and crunch on that.
Observations are past. These are things that have happened. Jobs is a future observation, is the distinction here.
Yeah. Okay. Let's go back. Do we have time to go through some of these? So for those who saw the demo room and saw the globe, that was an example of an API use where that individual is pulling down the current jobs and plotting them on a globe. The graph that Dan showed earlier of the growth of our daily active users was pulled from data on the network. We have some data downloaders and the Raspberry Pi that's sitting on the table there that you saw in the demo room was, again, another user who built a command line dashboard that pulls off the API. So whatever you want to do with it.
These examples, we're not going to run through these, but most of the time when somebody's doing something with the API or making a new thing, we write about that, make a forum post about that. And in that forum post is where you'd have a link to my GitHub page that does or GitHub repository that does that. So it's kind of the forum is a central place for kind of the new stuff that's going on. And that's where you would find the example code for some of these usage.
Yeah, definitely. If nothing else, watch the forums once in a while. You'll always see something cool. We'll show some of the examples at the end here. We went through satellite info on DB. We'll skip that. As we've alluded to, there's a global community behind this. It was kicked off in Athens, Greece, but we have, as you can see, developers and ground stations all over the world, and we're always looking for more. So, as Dan mentioned, the web forums are at community.libre.space, which I have open right here. And we have different categories on the left. Obviously, SatNOGS is a good category, but we have some other things going on as well. And on the right is the fire hose of the latest discussions going on.
You can get to that if you don't remember all of these links. Of course, they're in your handout. You can write them down. But satnogs.org, which is easy to remember, it has a direct link to the forums from that homepage.
Also, we have a very active community in chat rooms that are bridged between IRC and #SatNOGS and Matrix in #SatNOGS, as well as satnogs.-dev, which is where some of our development ramblings and discussions go. Documentation is another way to get involved and help and contribute. We try to keep all of our end-user documentation in the wiki, while our development documentation is stored with the code itself. So wiki.satnogs.org. We just rebuilt this and relaunched it within the last year with a new, cleaner user interface that doesn't suck as bad as MediaWiki does out of the box, while maintaining the flexibility of MediaWiki under the hood. So again, this is another site that you can sign into with your SatNOGS account, and if you see something that needs updated or improved, just hack away, improve it. We have good details here on antennas, different station ideas, different rotators that we have on the network. And under the operate link, you'll find good instructions on the actual websites and using them, and as well as instructions on building dashboards and decoders. Bob.
Sorry. So I went to wiki.satnogs.org, and how did you get to that documentation?
Click on build.
Oh, okay. Thank you.
And antennas, or just do a search for antennas, and you would find this page here.
If it seems like some of the wiki documentation is out of date, it's because it's not been updated. So this is why it's a wiki. It's a great place that you can do it by definition. Like developers, if you've been doing this for a long time, the wiki is fine for me. I know where all the information is. If I forget it, I know what I'm looking for. But if you're building a new one yourself, you're trying to figure out what to do. This tutorial today is kind of a walkthrough of all these parts, but the wiki is kind of that interface. If you're seeing problems of how you build something or the order of how you build something, you're like, man, there's just some background information that I'm missing. This is where, first of all, you can ask a question in the forums or in the chat channels. We're happy to help out. But then you are now, by definition, the most qualified to update the wiki, because we were blind to it.
Yeah.
And as long as you're logged in, you can update the wiki?
Yeah.
As long as you're logged in, yeah.
And with the rebuild, we added a WYSIWYG editor, so you don't have to do the media wiki code. This is actually a screenshot of the editor mode, so it looks very much like what the page ends up being. App developers, again, I targeted, called out students a while ago. If you're looking for experience and you want to do some code, we are an open source project, and we have a lot of code and a lot of issues that can be worked on. Our database and network websites are Python Django. The client is Python. The RF stack is GNU Radio. The data decoders we will get into at the end of, here, real soon. They're Kaitai structs. I'll show you what that's all about. If you're looking for a project, if you want some easy bugs to work on, we have some that are tagged as easy in GitLab, or you could reach out to us and say, I'm new, I want to contribute, what can you give me? Important note, our project is on GitLab, not GitHub. There is a repository on GitHub where we used to be. I think it might be synced. I don't know for sure. But if you go to GitLab, Libre Space Foundation, under SatNOGS, you'll find us there. You can also contribute with hardware designs. If you're EE or mechanical engineer, we have lots of hardware projects. We're working on pocket cubes, we're working on RF stacks, filters, LNAs, the rotator design here. You never know. Some people will post an idea to the forums, and others will jump in, and before you know it, you've got a KiCad design and a draft going. So if you're interested in this kind of stuff, you've got a project that you would like to be developed in the open and be open source and open hardware, this is definitely a place for that.
You could make someone could make, for the Tangerine SDR, there's the low-speed interface. You make what is it, a leaf? A leaf that's a rotator controller.
There you go.
For the Tangerine SDR, one box, modular, done. It's not there because nobody's made it yet.
Most of our electronic designs are done in KiCad, and the mechanical work that we do is often in either FreeCAD or OpenSCAD, which are great tools, as well as open source and free. All right, so I've just about caught up to, I think we can get everything done. Section 4 of SatNOGS, we're going to get into the RF stack and get into decoders. We're going to walk you through actually writing a decoder, in the process of writing a decoder. It's really cool. It's not as scary as it sounds so far. We're going to touch on GNU Radio and get into our data decoding structs. I'll just touch on this a little bit just to give you some exposure into what we have going on under the hood on the Raspberry Pi. We use GNU Radio with our own custom blocks on top of that. So we have a package called GR SatNOGS, which is all of the out-of-tree blocks that we need for our decoding and for the Doppler shift and what have you. You can see some of them here. I don't even know what some of these are, different syncs, different decoders, and somewhere in here is going to be the Doppler correction block. So if you're into GNU Radio and you want a project to work on, this is one that we're really working on and developing right now. There are a lot of satellites that we're not able to decode it within SatNOGS just because we've got to improve the decoders and the demodulators here within GNU Radio. So what we do is we have one script per mode out of that GNU Radio package, and so these scripts are what the client calls under in the background. You could call them directly and run them yourself if you want to try things out. Here was an example of running it against a weather station. NOAA weather station off of the Raspberry Pi. So we have a different script for FSK, a script for FM, a script for data under voice, what have you. So as more modes become available and as we have developers come on board, we'll write more scripts for more modes. Thankfully, most of them can be repurposed, and it's just a matter of changing a few blocks if you know your way around this. For those who are not familiar, this is what a GNU Radio flow looks like in GNU Radio Companion. This happens to be the flow for our FSK AX25 demodulator and decoder. So there are some of the custom SatNOGS blocks that are in here. The rest of it is just straight off-the-shelf GNU Radio. So if you're into GNU Radio, definitely encourage you to dive into this, get involved, help us write some more decoders and demodulators, and help us improve the ones that we have. As you can see here, there's the waterfall sync goes here, IQ goes here if you have that enabled. All of the AX25 decoded packets get dumped into files, and then the OGG is going to end up here with the OGG encoder.
If you're into frequency tracking and estimation, you know that we're doing the orbital prediction, the Doppler correction open loop right now, and we're not doing much frequency tracking. You know that's a big problem if you've ever tried that, but if that's what you do, this is going to improve. That would improve the quality of the decodes that we get from this system, and bring it in line with some of the other decoders like Direwolf or
Yeah.
Yeah.
So on to the fun part. Aside from conversations that I've had this weekend, has anybody in here heard of Kaitai? Oh, this is good. So anybody heard of Wireshark? Okay. So Wireshark allows you to define the type of a packet that's going to go across the network. That way you can easily and repeatedly decode that packet as you're looking at network traffic. Kaitai is the binary blob equivalent of that. So you have a binary file. In the first example that you open up is a zip file. That zip file is going to have a certain structure to it. It's going to have a header that's specified a certain way, and there's a struct to that. Kaitai is a pretty simple language that allows you to define what that struct is and what that struct looks like. And then from that file, Kaitai can generate decoders in a dozen different languages. So the most popular languages out there. For us, most of our stuff is in Python, but and we could have done this with Python constructor, I think is what it's called. But we picked Kaitai so that we have that future flexibility if somebody needed to come along and build or generate a decoder script in Java for some reason. Why would you? But it's going to be there. You couldn't. So that's the gist of Kaitai. The cool thing about Kaitai, at least for us, is that there's a great web user interface to aid in development of Kaitai, of these actual structs. So I'm going to walk you through some of this in real time. Hopefully it goes well. And if nothing else, if you come out of here, you'll at least have a little bit of exposure to a really cool tool for working with and decoding binary data and binary blobs. So if you want to follow along, you will need this first link, this file. This is a binary frame from Unisat 6. We've been poking on that satellite quite a bit today. So you'll want to grab that. This link is also in the handout if you can't see it on the screen. I'll leave this up for quite a bit here. The thing about Kaitai is that it needs to be in the binary format. It's going to look at it from a binary case. So if you were to do this at home and you're looking at the hex frame, you're first going to have to convert that hex frame to binary. We have some scripts in our decoders package that help with managing that. But for the sake of this, we'll start with this blob. And once you've got that downloaded, open up ide.kaitai.io in another tab. Don't let it scare you at first. I'll walk you through it. And in a third tab, open up this last tiny URL, which is going to be the telemetry documentation from the satellite operator for Unisat 6.
What's the
I'm screen sharing or screen mirroring here, so
what is the name of the BNF parsers, the language parsers, or the eBNF that'll render a parser in C? You write the language description. Yeah, KaiTai is this. Is that? It's the same concept, but it's for decoding binary data instead of. It's just a different language description. If you've ever written a data parser, you will love KaiTai. It will change your life. It's changed my life already.
Can you put back up that other wonder the URL is, please?
Yeah. And it's also on your paper too, so we'll give you another minute to open these up.
Is that file we're supposed to download only 90 characters, 82 characters? Yeah.
Yep. That's right. Yeah, the first URL is the data file, and it's just a few bytes.
Data2.us6, I think. Okay. All right, everyone with me? Okay. So yeah, download that file, 82 bytes, that's fine. We're also going to open up the info page. I need to increase this so you can see it. This table is what's going to be important to us. And we're going to want KaiTai.io. Oh, I also missed the documentation too. If you want to go to KaiTai.io and open the language reference under documentation. We're going to skip down all the way down to, the integers. So if you do a search for the integers heading, I'll be referencing this tab along with this one. So that gets us into the IDE. So what's this? Oh, you know what? I want to do this on a, let me do this on a fresh.
That's the end result.
Yeah. All right, so this is what you were all met with. And immediately, this big scary screen is the IDE for KaiTai. So let me walk you through this real quick. There is a list of files, like a file browser on the left. These files are a combination of what they have on their on the web. If I can collapse that and collapse this. And what you have in local storage. And local storage is actually browser storage. So in a minute, we're going to upload that binary file into this browser storage. So that's the files. If you want to look into formats and samples for this tool, there are all sorts of examples. It opens up a zip file by default. So it's actually got a sample zip file that it opens up here, and what you see is the hex representation of that file, or the beginning of it at least, and the KaiTai declarative structure for the zip file format. We're going to ignore this for now, because we're going to do our own thing. But at the bottom here, you're going to have, as we build this, you're going to see the objects begin to appear under the object tree. And the converter here on the very bottom right is helpful in identifying some of these objects. So for now, you're going to hit this upload icon. You're going to find the Data,
Maybe I'll be the pointer.
the data.us6, and it's going to throw an error, and that's fine for now, because what KaiTai is doing is you uploaded a file and it's trying to match it to zip, and it's not a zip file. So ignore the error down at the bottom, because we're gonna start over. Sorry, did you want this?
I'll feel useful.
All right.
I'm not related, but I feel like Vanna White right now.
So we've got our data file uploaded for Unisat 6. We're going to start a new file down here. So click New File. We're going to call this US6. It's going to be our decoder name. So now we have a pristine environment. We've started a new file. It's already started us with the meta headers here for US6, given us the ID name and a file extension, which conveniently maps to the file that we just uploaded. So we're good now. Here you see the hex representation of that frame that was collected from the satellite. Just to see, what I'm gonna have to do, let me switch this so I can get here. Oh, that's the wrong one. Move this over here. You guys can see that. You can still see the text in the back. Great. I'm going to have some notes here. All right, so first thing we're going to need to do, and some of this stuff I'm just going to walk you through it without explaining it, and just trust me for now, and we'll get to some things that make sense a little bit later. So we're going to start with endian. This is a setting. We're going to set this to little endian, since that's what the format is for this. That'll help in some of the shortcuts that we can give later on. So
there's two spaces. It's a two-space indent for this.
Yeah.
Is it indentation that for human benefit, or is
It's for the language as well, yeah. Yeah. So with KaiTai, there is the concept of sequences and types. And caveat here is I'm not a KaiTai expert. I've dabbled in this and discovered it as much as everyone else in the team, and it's, we've found it beneficial for this purpose. So I'm sharing the love we've found for it. So what we're going to do is you'll see a sequence up at the top. That sequence is going to say this frame is going to have blah, and then it's going to have blah, and then this, and then that. And those objects might be of different types. Well, within a type, that object may itself have a sequence of items inside. So this is going to start to make a little bit of sense to those of you who are familiar with packets as we start this. So we're going to start with our sequence. Yeah, didn't need the spaces there. Oops. We're going to do ID. We're going to call this AX25 header, since that's what's going to be the first thing in this frame. And for this AX25 header, right now, we're not going to go into decoding an AX25 header, but we know it's there, and we know it's going to be of size 16. And what happens is, immediately when you set size 16, the IDE over here on the right highlights that block. So you have a visual representation of what that is, and this, for me, is not showing everything to the right. So let me see if I can, there we go. Okay, that looks a little bit better. So let's see, we go all the way down to the PID of F0. So this, we can assume that this is legit for now. We can go back, later. And in fact, in the final decoder for this satellite, we have gone and actually written the decoder for the header. But that also involves a little bit of bit shifting with the call signs. And I don't want to get that deep right now. I just want to give you a taste for what this is. So we're just going to tell the processor that it's, you know, it's a size 16. We're going to leave it there. Oops, wrong window. So the next one after the header is going to come our frame. So we're just going to call it frame. And we're going to give it a type of frame, which we haven't defined yet. So it's probably going to throw, yeah, it throws an error, says, I can't find it. As you type, this thing is really, it's trying to process everything in real time, which is why this becomes a beneficial tool to be able to hack your way through some of these figures. And I'll show you how to do that in a backwards way here in a second. So, types. 2 spaces after types, we're going to have a frame type. 2 spaces after that. The frame is going to have itself a sequence. So the sequence, we're going to start here. This is starting to look a little familiar. Let's see. The first thing, if we go, I have to juggle some windows here, so apologize.
This is where you have...
I don't have to juggle, I have to switch there. Sorry, go ahead.
This is where you have two screens up. One is this IDE, the other one is the documentation of this data format.
So the header is assumed, and now we get into the frame, and this is where the satellite operators have given us a documentation about what the frame looks like. We're not going to go through this whole thing. We don't have time. I just want to give you a taste and how to go about doing it. So the first thing that they say is that there's this sync packet, but there are 3 bytes of these unsigned integers for a sync packet, and that sync packet contains the bytes US6 for Unisat 6. So what we can do is we will then tell KaiTai that that is going to be a sync packet. We're going to say it's going to be 3 bytes, and we're going to give it what the contents are. And if the contents of a frame do not match what those contents are, it's not even going to decode it. It's a bit of a check. So that's our sync packet. KaiTai knows how to handle that. So let's go back to this, and the ID will be sync packet. And the size is 3, as we just said. And contents. Now, a couple of things that we can do here. So already it's highlighted the next 3 bytes here. So it already knows, okay, there's what we call the sync packet. Here, this is reserved. This is the hex representation, which is what KaiTai is going to look for in the contents. So for this, we're going to say 55 hex, comma, 53 hex, that was a yes, 36 hex. Suddenly, our frame comes back, and our sync packet is there. And if you click on this, it will decode into various different values, so you can try looking at different ways of representing the data itself. But what we have here is US6. So, sync packet, good. On to the next. Oops, not that one. Where's my cursor? Why did I lose my... This is a bad time for this to not work. Oh. Okay, there we go. I'm a cursor back. I'm breaking it now. Okay, so next one we will do, let's see, on the right line, nope, dash, and then ID. So if we go back to this, we're given packet index. It's an unsigned integer of 2 bytes. So we're going to call this packet index, and then instead of giving this just a size, we're going to give this a type. If I can find where I put this. Here we go. Sorry, juggling too many windows at once. So if we go back to the KaiTai documentation, we're going to look for an unsigned integer type. We've already assigned little endian to the entire decoder, so the unsigned integer is just U. And here we can do U2 because it's a size 2, or U1 for size 1. We can leave the LE off because we've already assigned that to the entire decoder. So
KaiTai is naturally byte-based. That's why it says U2 instead of U16. And so if you have frames that are not on byte boundaries or information that's not on a byte boundary, it gets interesting.
Yeah. Yeah, it's possible, and we've done it with the Fox satellites, but it's not pretty. So type U2. Now we've got a packet index down here. We're gonna assume that's okay. We're gonna keep going. So next is if we look at this, it's gonna be ground index. So I'm gonna shorten this to G&D index and another size 2. And for the sake of time, I'm going to keep going here until we get to uptime and Unix time. So the next one is packet type, but that's only a 1. Payload size. That's another 1. Payload size, reboot counter. That is a 2. And now we get to uptime, which is a much bigger one. That's going to be a 4. Okay, I'm going to pause here. We remember uptime was in milliseconds. We could kind of check this and check some math. But the next one is Unix time. So this is another spot where I'm running quickly with the assumptions that all of this data is good. But let's say we're looking at a packet, and we've gotten to this point. We're not sure what some of this is, but we're looking at the next 4 bytes. We can do a shift click, or a click and drag. You can click and drag, and now at the bottom, as you're doing this, KaiTai is trying to decode what you're selecting into a multitude of different formats, because it doesn't know what you want yet until you define it. So we can go down here, and let's say, we look at the documentation, or even if we don't have documentation, we're just poking around. This looks suspiciously like it might pass for a Unix time. If you're unfamiliar with Unix time, it's the amount of time since 1970, January 1st, 1970. That's just always incrementing. So we're going to copy this. Let's copy that figure. We haven't defined it in KaiTai yet. Let's see.
So is this a reasonable Unix time? If you know about Unix time, you might have an answer already. And if you don't, this is what Google's for.
Yep. So we're going to enter a timestamp that we just pulled from that IDE. There you go. September 14th.
So KaiTai is doing that, drag this line up a little
Does it really?
So pull this boundary up.
Oh, really? Oh.
There it is.
Thank you. Man, below the fold, everything
Isn't
gets lost
Kaitai
below
cool?
the fold. So I did that Google search for nothing, but here we have our next ID, which we've already verified, and we know now, and for whatever reason, this is gonna fight me on this. So we've got ID Unix time, and that is type E4. And there we have that same value. So now you're getting a little bit of a feel. I'm going to stop here because I have tons of stuff and 17 minutes left. But this is an awesome tool. We can go in and, if we had time, we could go back and set the type for the AX25 header. And then within that type, we would start to decipher the little bits of the AX25 header. If you want to see eventually what it looks like, I need a mirror here. It's something like this. We also, internally, for our use, we use doc strings within Kaitai to then map to our decoders within SatNOGS. So you see a lot of doc strings here, but this is what it then ends up look like. The sequence for the X25 header, you see all of these call signs, and then there's a set of steps that you have to take with the call signs to actually decipher it. There's a bit rotation to do, but that's more advanced stuff.
How do we save this stuff?
So this is going to be saved within your browser cache. So your local browser storage. So if you open this again tomorrow, you'll have all of this stuff in the files. No? Really?
Is there a way to?
You could also download it. There's this export link down here.
No. Where is it at? That one? Is it that one? It's grayed out.
Why is it grayed out? Oh, yeah, you have to select it. Yeah, so if I select this and then hit download, I'll get a pop-up. There you go. Yeah, see, all of this stuff is saved in my browser cache. So, I mean, definitely don't trust that. Save your work.
It may depend on your browser.
That's true too. Yeah.
This is the so this file here is the one that you're writing and that you want to download or back up, and that's what gets pushed up to SatNOGS, is what the network uses. It takes that KSY file and does its processing. Questions?
Yeah, can you easily handle what PLV values, PLV fields, type length value? Is there variable length here?
Yes. Yeah, it can handle that. And if you go back to the zip file example, because you don't know how long the data is going to be in the zip, but you can see how it's handled there.
Variable length fields was the question?
And it can also handle casing. So a satellite may have 4 different packet types, and it's going to depend on a certain field, what that packet type is, or in some cases, it's going to depend on the sequence of that packet. You can handle all that stuff as well.
It's not just variable length fields, TLV, because the field type is defined by the byte in the header.
Mm-hmm. Yeah.
And it can be in any order.
For those of us who want to play with this more, how do we get your KSY file so that we can go back and?
Next slide.
The question was how do we get KSY files that are non-blank?
Yeah, all of this stuff is in this GitLab repository. Again, we'll have a final slide here in a second. You can screenshot or take a picture of that slide and have or that URL and have all these slides at home. But that's where all of our decoders are. There are ways of programmatically running these decoders from the command line, and we have scripts to do that as well. The IDE is just enough to catch your interest.
And we will have your PDF or slide set so we can
Roadmap stuff, you can read that later. I want to get to the cool stuff. So let's see. Some of the cool stuff that's happened in the last year or so with SatNOGS. I think John, is that your name? John, you talked about Dwingloo. Let me open this in a new window. So if we go to our rotators page, you can see all the rotators that we support on the network, the ASU, AlphaSPID, and the Dwingloo Radio Observatory. Yes, this has been on the SatNOGS network a couple of times, actually. I thought this is really cool.
Crappy RTL, SDR, and a somewhat unique antenna.
You have an antenna that nice,
So
it doesn't
the
matter
video
about your
telescope,
receiver.
which is now tracking the PRISM satellite, which will be sending Morse code. And you can see it tracking here. Position, azimuth, and elevation is slowly changing.
This entire
And
room
in fact, if you
moves
look
with
outside,
the telescope, so you can kind of see the movement in the background.
you may be able to see the telescope slip ever so slightly. Check the engine. Check the engine. Yeah, okay. Engine room. This is the engine room. And there the gears are running. And the engine that's controlling it.
So that's about it on that video. Now the video is one thing. The results are another. So here's the station page in the SatNOGS network. If you want to go browse the observations that have come off of this radio telescope, it's all right there. You have to click this link right here that says View All, and that's a shortcut again to the observations page. One observation that I will pull up real quick. This was a favorite of mine because there was so much data decoded from this on a 3-degree pass, max 3 degrees. You can see clearly all that data, strong signal, with that little blue RTL SDR dongle on a laptop in the Dwingloo Radio Observatory. So that's, go back to where my, yeah, it does, yeah, exactly. ISS, SSTV events have been pretty popular lately. We love them because we take it up to the next level with a global network. So this was, every time this happens, somebody will post to the forums with collecting all of the results that they can, calculating the results, doing all kinds of whatever statistics. For this one in particular, I just picked it out at random because it was recent. The total duration of the event was 3 days, 34 minutes. We covered a whole day and 2 hours of that across our network. You can see a plot of the global coverage of all the stations and the passes of the ISS for that. Some of the images, I think how many?
1,300 observations?
251 images decoded from that, so a little manual work in picking out the top 12. But then you can go in and further and say, okay, whose station was good for this and whose was not? Where did we get good data? Where didn't we? What can we learn from this? It's just taking data to a whole new level. So there was a script years ago to track high-altitude balloons with one of the ground stations. I don't know where that is. I think, from my perspective, I would much rather go Bob's idea and Bob's route of setting the beacon to the satellite frequencies when it's over the ocean, and then tracking them that way. ISS, we do every AR ISS school contact. We will schedule as many ground stations for that contact as we can, and then post the results to the forum so that there's an archive of that, as well as something that kids can go and replay for their parents back home. In this case, as you can see, there were many stations scheduled, and this is what the the past looked like, what all of the stations were, and the little red icon is where the actual contact was being made with that school.
You won't hear the uplink in these,
Yeah.
so this is just the downlink, the astronaut answer side.
Yeah, yeah. But, you know, they're general questions. Like, you
They-
hear an astronaut start talking about their favorite food in space, you know what the question was. Analysis. All this data with the API and everything, the opportunities for analysis are just endless. The fact that we keep the TLE that was current to the observation with the observation data means that we can go back in time and say, well, where did this packet come from in the orbital sphere? And we know that it was decoded, so it was a good packet, and so there was good reception there. So just yesterday, yeah, somebody posted to the forums, this is one of our core contributors, not somebody, Freddie, posted to the forums with analysis that he had done across all 800 or 900 stations with a plot giving the success of decoding packets on an ASL sphere. So you can start to see, you know, what your antennas are like. I've got this weird dead spot. I know 45 to 90 degrees, this is mine, is a dead zone, but you know, I'm not sure what that is. And I know that this is a wide open space. I've got good coverage there. You see all kinds of stuff. I will point out for, whoops. And like I said, 900 stations. This was just posted, so there's a lot to dig through and learn here. Going back to omnidirectional stations and their effectiveness, we can look at 488. This is one that we pointed out in a slide that Dan was talking to earlier. Let me zoom in on this. This is a station on the Oregon coast using 3-element UHF Yagi pointed straight up. You can see the coastline in the background. You can kind of see the orientation of the Yagi, so you can see that the elements are kind of pointing east to west. What does that mean and look like for his data success? You can kind of see where the lobes are. So, 5 minutes, good. I'm good. Let's see. So again, that was just posted, but there's plenty of data to play with in terms of trying to analyze and look at different antennas and different statistics. We've had a ground station set up at the Chabot Space and Science Center, which is a excellent space museum and observatory in Oakland, California. If you're ever in the Bay Area, you've got to go there. It's really cool. Go on the weekends. They have the observatory telescopes open. It's great. But they have a new exhibit that's like mission control for NASA, and they put SatNOGS up on the wall with that, as well as their own ground stations. So they've made that a part of their exhibit. And again, one more visualization. I mean, any way you can cut our data, we love to see it. This was a year old, and I just asked Freddie to redo this for this weekend, but I asked him a number of hours ago, and I can't expect a response. So let's see if this visualizes from 2017 to 2018 all of the data that was collected and where it was collected from.
If you remember, 2017 was the start of that growth plot where it was very little, and then you can see just the activity.
So with that, I know we're out of time, and we're going to have to vacate the room soon. I am happy to stick around for as long as we have questions for